see. Let's go. Question number 1. A normal to parabola meets the curve again at Q. Then the length of the normal chord is this thing. Well, first of all, what's the normal chord? So this chord, the other guy is going to be T2 is equal to negative T1 minus 2 upon T1, right? So just want that length between these two. So how do we get that? It's like just find the square of that, and take that A out. Gonna add the last step. So really it's just going to be T2 minus T1. So square of these, in fact, that thing square, and then you got, so it was 2t, yeah, you get that. It's like 4 times of T2 minus T1 squared, and then 8 times of all of this square root. You get the idea. So this is like 8 times of T2 minus T1, because you can take that out. Then you got square root of, look, T2 plus T1 squared plus 4. So right, T2, yeah, just leave it like that, because yeah, so T2 plus T1 squared plus 4. And that should do it, I think. Okay, so let's do it. What's T2 plus T1? It's going to be 2 minus 2 upon T1, right? So it's going to be 8 times of T2 minus T1 square root of, it's like 4 plus, okay, this thing is just minus 2 upon, so it's going to be 4 upon T1 square, which is going to be like 2a T2 minus T1 and square root of 1 plus 1 upon T1 square. What is this is going to be? Like, it's going to be, oh yeah, so it's got 4a, and then this is going to be, so this is that. That's why, oh, and by the way, there's negative and whatever, but we only care about the length anyway, so might as well just put a mod, right? And then those negatives don't matter, so it's gonna be, do the normal way. Nah. So this thing minus T1 minus 2 is out, just minus T1, or that minus is not there, then plus 1 upon T1, and then square root of 1 plus 1 upon T1 squared. Oh, and this is equal to what? This is equal to k square root, to find k. Oh, and you also know what T1 actually is. So y squared will be 4, right? Okay, A is going to be 2, and then 280, which is going to be 4t, is equal to 4t has to be 1. So T1 has to be 1. Let's put that in there. 4a is of course 8. Is that correct? Of course, I mean, like, A has to be 2, and then this has to be 1, right? So there we go. So you got 8, and then this thing is just, 1 plus 1 is 2. So 8 into 2. Square root of 1 plus 1, so square root of 2. So 16 square root of 2 is our answer. So k, oh, it's supposed to be k squared. So k is going to be 4. First 4. Next, second question. A tangent to y squared equal to negative 4ax meets the parabola y squared equal to 4ax in P and Q. If the locus of the midpoint of segment PQ is y squared equal to aax upon b. Okay, so first you got this parabola, then this parabola. Tangent to this parabola meets this parabola in P and Q, and you want the midpoint, right? Oh, so this has what kind of, so it's got y is equal to, you might as well think, okay, it's like 4 times of negative ax, so it still works out. Y equal to mx plus a upon m, and this is, it's going to be like negative a, so negative a upon m, right? And it just flipped basically. So yeah, I mean, right? Okay, do I really need to show you what's going on? So this is the thing. These are our two parabola. This is the y squared equal to 4ax thing, and this is y squared equal to negative 4ax. This thing is like, okay, so you got this slope, it's gonna be like this. This is negative right there and everything. Yeah, no big, and then this same thing would be over here, but then you got positive. Yeah, I don't need to explain this. It's obvious. Okay, and then this is cutting in P and Q to this parabola. Just put that in there. You get the, central point and whatever, right? So, okay, let's just, instead of putting, let's use the other form, which is yt is equal to x plus 80. It's going to be negative 80 square in this case. So just put x is equal to yt plus 80 square in this thing. So it's going to be y squared is equal to 4a times x is just yt plus 80 square. So y square minus 4at minus 4a square t square is equal to 0. So y1, y2, I mean x1, y1, x2, y2 are the roots of this equation. So of course y1 plus y2 has to be 4a, half is like 2a. So y mid is, just 2a, but then the midpoint actually lies on this thing, right? Oh, sorry, 2a t is supposed to be y. What am I doing? 2, yeah, right, it's supposed to be 4a by t, yes. And then it's supposed to be 4a square t square, right? It's good. Yeah, so we got that. And what about x mid? So x mid is just, so from this equation it's just yt plus 80 square. So this time c is like, what is this? 280 square, and then that plus 80 square is 380 square. So there we go. Just square this up. So like y mid square. I'll just use x and y directly. So x is equal to 380 square, and then y square is equal to 4a square t square. Just divide, you get y square is equal to right. So y squared upon x actually. That's gonna be equal to 4/3 of a. Yes. So y squared is equal to 4/3 of ax. Okay. And this is equal to, oh, and by the way, okay, that a is still there. A upon b, that's going to be 4/3. So a plus b is 7. This should give us that a and b are co-prime, but whatever. Next question. Third, the shortest distance between the curves, this curve and that curve is. So this thing, then find, right. So this and, oh, some kind of circle, right? Okay. X minus 12, no, it's like y over there. X squared plus y minus 12 squared is equal to minus 128 plus, well, what, 144, right? So it's going to be what? 40 minus 8 is like 6, and then you got 3 minus 2 is 1, 16. So radius is, okay, whatever. So 0, 12, somewhere over there. Radius is 4. Is that correct? It must be, right? Yeah, right, it must be correct. Yeah, of course. So radius is 4, and this is at 12, so it's going to be like this. It's like 4, 4, 12, something like that. And the other parabola, what was that? It was y squared equal to negative 4x. So something like this. No, sorry. Okay, that's for second question. What was the third question? Y squared equal to 4x. So like this or whatever. So at x is equal to 1, we'll just have y is equal to 2. So something over here. Yeah, you get the idea. Okay, that's our parabola. And you just want what? The shortest distance between these two curves. That's like saying, okay, you got this thing, you just want, oh yeah, so just, I mean, this is parameterized as, t square comma 2t. And then this point is just 0, 12. What's the shortest distance between them? So the square distance is going to be what? T power 4 plus that's 0. And then you got 2t minus 12. Wait, that's minus 12 already. No, that's plus 12. It's supposed to be, yeah, okay. Understandable. So distance between this point and that, right? So 4, and then you got t squared, or you just say right away like 2t minus 12 squared. And we want to, of course, like minimize this thing, right? Yeah, this is like t power 4 plus 4t squared minus, oh, this is going to be not good because, right, it's a, oh, this is not nice. Maybe you just need to, okay, figure out some kind of normal that passes through. Yeah, you could do that. You could do that, of course. So the normal will be y is equal to negative tx plus 280. In this case, a is just 1. So plus 2t plus 80 cubed. Still a cubic. Not nice. Okay, and then 0, 12 is passing through this thing. So it's going to be 12 is equal to 2t plus, oh, a is 1. So it's like t cubed. So t cubed plus 2t minus 12. Kind of request cubic. Okay, you need to figure out its factors. Any obvious solutions. So 12 can be factored out as 4 and 3 or something. So 3 maybe, okay, you got 27 and okay, 3 won't work. What about minus 3? So 27 minus 18. Is that right? No. Oh, sorry, minus 6, and then that would be 18. Okay, that doesn't work. What about minus 2? So minus 8 plus, okay, what about plus 2? So 8 plus 4, yeah, it works. So t equal to 2 is a solution. Just put t minus 2, right? That's what we want. Just divide by that, t minus 2, and then you got t cube plus 2t. That's no square term. Plus 2t minus 12. Let's do it t squared. So minus t cube minus 2t squared. Subtract it out. You got 2 squared. 2t squared, and then you got plus 2t. So plus 2t. So 2t squared minus 4t. Is that right? It's got to be, subtract it out. Yes, it's right. Okay, subtract this out. It's supposed to be 60 and then minus 12. The fact that it actually worked out is good, right? It's a correct thing. So this is the other factor. So either t is 2 or this must be 0, which makes no sense because like t plus 1 squared plus 5 will be no. So t has to be 2. T has to be 2, right? So now we know what that point is. It's just going to be, oh, and by the way, a is 1. So like t squared comma t, that's going to be what? So t is equal to what? 2 once again, right? It's going to be 4 comma 2, and this is just 0 comma 12. So the distance between them is like square root of 4 square plus 10 square, I think. Is that the thing? Of course. I mean, it has to be 4 comma 4 comma 4. Sorry. Yeah, right. Because t square comma 2t, right? That's the thing. Okay, so 8 square, which is 4 square root of 1 plus 2 square, which is okay. It's like 5. 4 square root 5 is that distance, and then this thing minus the radius. Radius was just 4. So there we go. 4 times of square root 5 minus 1. That's the thing. 4 times of square root 5 minus 1. So a has to be 4, c has to be whatever. It's like a plus c. So with this thing plus that thing, so 5, and then minus b. That's 0. So third answer is 0. Next question. Next we got fourth. Fourth is the shortest distance between the curves, this curve and that curve. Wait, okay, isn't that what? Oh, that's just the third question. Sorry. Fourth question is two tangents to the parabola. This parabola make angle A1, A2 with the axis. The locus of their points of intersection. Chord of alpha 1. Oh, this is supposed to be alpha and alpha, whatever. Oh, it's like saying that, M2 upon M1, right? It's 1 upon that. Yeah, that's equal to 2. But then M is just 1 upon T. So, and you just want, wait, yeah, two tangents, of course. With the x-axis. Yeah, it's a thing. So, what does that mean? Okay, this is supposed to be, T2 upon, no, T1 upon T2, sorry. That has to be equal to 2, right? Locus of the point intersection. So it's like T1 is equal to 2 times of T2. We'll just say, okay, one of them is 2T, the other one is T, right? And you want the point of intersection of these two. Okay, we know what that is. It's going to be A T1 T2, comma A times of T1 plus T2, right? That's the point of intersection. So it's going to be what? A common. We don't care about that. T1 T2 is just 2T square, whatever that T might be. And then this thing is just 2T plus T, so 3T basically. Right. So what does that mean? That means y upon a square, that's equal to just 9t square, and then x upon a is just equal to 2t square. Just divide this. So y squared upon a squared, and that thing upon x upon a is going to be y squared upon ax. That's equal to 9 upon 2. So y squared equal to 9 upon 2 ax, right? Where did that question go? Oh, so it's like 2y square is equal to qax. So q must be 9, of course, because 2y square. Yeah, right. So final value of q is going to be 9. Is that square? No, q is 9. There we go. Next question. Must be correct, right? Yeah, whatever. Next question. Fifth question. If a comma b is the coordinates of point y squared on y squared equal to 4ax, which is closest to 2 comma 0, then a plus b plus 2 is. Oh, 2 comma 0, it doesn't pass through that. Okay. Oh, isn't 2 comma 0 just the. No, it's not. It's not the focus on anything. Okay, so a comma b is just the coordinate of a point on. Which is closest to this. Hey, okay, so the condition for 3 conormal points, what was that? Sorry, 3 conormals, concurrent normal was right. So for that, you should have h bigger than 2a, right? This guy has, so h is just 2 and this is 2a. Oh, these are all the same. It's not bigger than 2a, so it's not going to be 3. Oh, it's supposed to be, I think it's supposed to be 0, 0, but still, we'll just figure that out. So the normal is just going to be, y is equal to negative tx plus 280a is just 1, so 2t plus t cubed, and you're saying this passes through this guy, so 2 comma 0, put that in there, so 0 is equal to negative 2t plus, okay, it's obvious, t has to be 0, that's the point closest to it, or is it the farthest point? It has to be 2 comma 0 right there. It's supposed to be t cube equal to 0, or like, yeah, that's the thing, it's supposed to be t cube equal to 0. There's only one way, it's supposed to be the origin, right? Okay, fine. So then 0 comma 0 is that point. Yeah, so like a plus equals 2 is just 2. Fifth, 2. Does this make sense? So 2 comma 0 is just some point over here, which is the focus. It's going to be 2 times of that over here, or okay, yeah, it's actually the thing. Next question. Sixth. 2x plus y plus k equal to 0, k is a constant, is a normal to this thing, value of k upon 3 is seriously. Okay, so what's the normal? It's just y is equal to negative tx plus 280 plus 80 cubed, right? In this case, a is what? It's supposed to be 2. So 4t plus, 2t cubed, whatever. So, right, it's got, tx plus y. Okay, so t is up. Oh, it's negative. Shit. It's supposed to be negative over here as well, that is. Huh. Okay. So tx plus y plus 4t plus 2t cube is equal to 0, whatever. What's t? You can see it's supposed to be 2. Then k has to be this. It's like 8 plus what's this thing? 8 times 2 is 16. So 24, right? 24. And that thing upon 3 is supposed to be 8. So there we go. This must be 8. Next. Yeah. Yeah, of course. Okay, next. 7th. The slope of the common tangent to the parabola, this and this is m. So common tangent these parabola. Find the value of negative m. What's happening to my mouse? So okay, this is easy. So like first guy is very easy. Y is equal to mx plus a upon m. A is 4, so 4 upon m. But this guy is slightly different. So yeah, okay. You can use the same thing, but now you gotta use 1 upon m. So 1 upon m times y plus, you just have a upon m, but this time, okay, a is 1 upon 2. And then m, instead of that, you're gonna put 1 upon m because that's dx upon dy. So the inverse, and you get the idea, right? Oh yeah, right. So just multiply by m. So mx is equal to y plus, and this is like m already, so just half m squared, of course. So y is equal to mx minus 1 upon 2m squared. These must be the same. If it's a common tangent, that just means minus 8 is equal to m cube. M has to be negative 2. So negative m is just 2. The next question. Consider the feet of normals from this to that. The arithmetic mean of the ordinates. Seriously? Ordinates just the y coordinates. I mean, t1 plus t2 plus t3 equal to 0, right? Yeah. So, of course, it's supposed to be 0. Yeah, I mean, it's the standard parabola. You got this feet of normal from this. Yep, it has to be 0. T1 plus t2 plus. So that's also like y coordinates added up to 0. Yeah, okay, ninth. I mean, assuming the ordinates are like signed quantities and not lengths, most likely they are signed quantities, right? Which is the y coordinate. Okay, ninth. If it was like the abscissa, then that would be more interesting, but whatever. Ninth. AB is a focal chord of pi squared equal to 4ax, where a is this thing, BC is the normal at B, the circle ABC cuts the curve at D. AB is a focal chord, A is 4a, 4a. Huh? So 280 is supposed to be 4a, then t has to be 2. So the other guy, so b is just, t equal to negative 1 upon 2. Okay, bc is the normal chord. Just write it down actually. A is supposed to be 2, and b is t is equal to negative 1 upon 2, right? Okay, bc is the normal chord at b. Okay, normal chord. Oh, right. Okay, so you can figure out what c is. Circle ABC cuts the curve at D. Okay, you got this circle and that cuts this curve at, wait, what? At D. The coordinates of D are, this is weird. Oh wait, isn't this like, okay, it's also a, let's just say it's a special case of conormal chord. So you got A somewhere over here, essentially over here or something. Like it's very far away. B is over here or something. Normal to that, I don't know, I'm gonna cut somewhere over here, I think. Any case, that's just gonna be C. Okay, cool. So you're saying the circumcircle of this guy, right? Cuts the curve at D. So think about it. If your B was not exactly over here, right? We by the way, no, this has to be like normal. So right from there to there is normal. From A to B, it's not a normal. That's problematic. Oof. Okay, the circle. Wait, I think it's doable. So A and B. Okay, it's supposed to be like that. It's supposed to be normal to that thing. Right. Okay, their tangents are normals. Their tangents are perpendicular. So for A and B, the tangents, since we do it the right way. Focus is somewhere over here. That's AB. their tangents are, you know, at 90 degrees. Doesn't look like that, but assume it's 90 degrees. And then somewhere over here you got C point. This thing has to be normal to the tangent. Wait a second. Oh, okay, okay, this is exciting. So you got, okay, look at this line. You know, perpendicular to that, somewhere on this, you're gonna have A. You got this B over here, perpendicular to that. Somewhere over that, you're gonna have C, right? Oh yeah, sure. Okay, 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 okay. It's normal chord and everything. Huh, what do we do with it though? You want the circle passing through ABC. I mean, if this was not, if this was, you know, perpendicular as well, it would be really nice, but it's not necessarily perpendicular. Oh, come on. Coordinates of D are this, then P plus. Okay, you just have to do it the, you know, the original way. There's no easy trick to do this thing. I wish there was. I mean, just if, you know, A was some kind of special thing. Yeah, fine, just do this thing. Right. Wait, it maybe, think about it. The tangents are, you know, yes, normal supposed to be. Okay, whatever, just do this thing. Just, you know, figure out ABC and then you are done. Right? Yeah. The circle cuts this somewhere, whatever. So C is, you know, what was this minus? So it's normal from B is gonna cut at C, so it's minus T, which is minus 1 upon 2, and then minus 2 upon T, which, oh, minus, sorry, and then minus 2 upon T is like plus 2 upon 1 upon 2, which is 4. So yeah, okay, 4 plus 1 upon 2, that's the thing. Not really nice. And it's supposed to be cutting at D to call. Hey, wait, it's a circle passing through a parabola at 4 points. You know that those 4 points must have coordinate sum equal to 0, right? T1 plus T2 plus T3 plus T4 equal to 0. What does that mean? Oh, we can just figure out the other guys by summing and making this negative. Summing, just get 6, negative, negative 6. So the other guy, T of negative 6 is the point. So, and A is, we don't know what A is, right? But okay, so 80 square is supposed to be 36A, and then 280 is supposed to be minus 12A. There we go, that's our points. Okay, the coordinates of D are this, then P plus Q upon 4A, P plus Q is just 24A, and that upon 4A is supposed to be 6. There we go. Next question. I thought it would involve co-normal points and whatever. Nah, just involves this circle passing to parabola. Parabola y is equal to 4x and x equal to 4y intersect at angles pi upon 2 and tan inverse of x upon y. Okay, then y minus, oh wait, oh, so this is like not related to the coordinates, just some numbers, right? So x equal to 4y, something like this, and y squared. So here they cut at 90 degrees. We got this other point, which let me just guess, 4 comma 4, right? That's the point. So 4 comma 4, yeah, these cut over here. Okay, so for 4 comma 4, the tangent of this is going like 4y is equal to, you know, 2x plus of whatever. The thing is 4y, right? So that's what important. So this guy has slope of, you know, 1 upon 2. So plus 1 up constant, we don't really care. For this guy, it's going to be just 4x is equal to 2y plus some constant, we don't know. So this guy's slope is equal to 2. So these are just reciprocals of each other, right? Okay, that's not important. So like, okay, these are reciprocals, and just figure out what the angle between them. What's the tan of the angle? It's going to be 2 minus 1 upon 2 upon 2 upon 1 plus 2 times 1 upon 2, which is just 1, right? This would just be, you know, 3 upon 2 upon 2, I think, right? Which is 3 upon 4, tan inverse of 3 upon 4. Yeah, then y minus x is just going to be 1. Next question. 11th. The locus of midpoints of a system parallel chords with slope 4 to the parabola. What's this 7y squared equal to 25x is this thing. Then k is, oh, so you just want, okay, you've got a bunch of chords, you want the midpoints of those, right? And slope is just 4. Hey, so slope being 4 is like, okay, that's just 1 upon t1 plus t2 is equal to 4, right? You know the slope between these two, right? Yeah, and then what else? You just want the midpoint of these guys. Right. So the midpoint is, oh, that just means like T1 plus T2 equal to 1 upon 4 or whatever. And the midpoint is, uh, so A times of, it has y coordinate of A times of T1 plus T2. That's the main thing. What does that mean? Yeah, like A upon 4 is the y coordinate constantly. So just, y equal to A upon 4. That's the thing. Right. So y is equal to A upon 4. A is just, this thing, what thing? 25.28. Right. And all of that times 1 upon 4 because this thing. So it's going to be 25 upon, you already got 7. It's like 7 times of 4 square. That's going to work. So 7y is equal to, you want 56y is equal to something squared, huh? That's weird. This is for sure, right? 1 upon t1 plus t2. No, 2 upon t1 plus t2. Because, what was the thing? Just do it once again, like 2a, and then you got t1 minus t2 upon a times of t1 minus t2, and then you got t1 plus, yeah, 2 upon t1 plus t2. That's the thing. That's equal to 4. So, like, this is actually equal to 1 upon 2. It's supposed to be 1 upon 2 right there. So, then it's just going to be, what's this? Is this already just 56? Yeah, it is actually. So, there we go. K squared is just 5 squared. It's 5. Next, 12th. The number of common tangents to the parabola y squared equal to 8x and x squared plus y squared plus 6x is equal to 0 is. Okay. Common tangents to this parabola, and just draw this out, so just got this thing, and you want common tangent. And this is, what is this, like x plus 3 squared plus y squared is equal to 9. So, right, I mean, it's centered at, it should have been obvious. It's just negative 6 comma 0 and 0 comma 0. So, right, like this, huh? Then you just want common tangents to this thing. Well, one is of course here. What about the other ones? You will have either 2 more or none of them, right? So either it's 1 or 3. So let's see if you can find something like that. So once again, what's our parabola? Just actually draw it out, right? Okay, our parabola is just y is equal to 8x. So our tangent will just be, y equal to mx plus 2a upon m, which is supposed to be, so a is just 2. 2a times of like 4 upon m, I think. Right? Yeah, okay. Wait, did I previously just use a upon m somewhere? I don't think that's correct. Did I use that somewhere? Wait, I think I'm messing up somewhere. Yt equal to x plus at square. Isn't that the thing? But then it's supposed to be a upon m, not 2a upon m. Yeah, it's not supposed to be 2a upon m, it's supposed to be a upon m, right? Because y equal to mx plus 2. Yeah, okay, what am I doing? It's supposed to be 2. The thing is, I have not been in touch for this topic for, a bit of time. So y equal to x plus at square, from that you get this thing. It's okay, no big deal. Sometimes it happens. So that's the thing. This is our tangent. You want this to be touching this guy, not 2a upon m. Right, so just put negative 3 comma 0, and there you should just get, you got negative 3m plus 2 upon m, mod of that, whatever, upon square root of m squared plus 1. That has to be equal to 3 if this has to happen. Then just square this out, I think, yeah, or you just divide by that. It's like 1 plus 2/3 of m, m plus minus, sorry, 2 upon 3m. That thing square has to be equal to m squared plus 1. That's one way to think of it. It's got m square plus 4 upon 9m square minus, so 4 upon 3, that's equal to m squared plus 1, I think. Cancels, let's go over it. 4, okay, 4 upon 9m square is equal to 7/3, right? So m square is just equal to 4 upon 21, I think, right? So slope is, it's actually possible. Then this means there are supposed to be 3 tangents. There we go. Where did it go? Where's the question though? It's the question number 12, right? So number of common tangents is supposed to be 3. Okay, next question. 13. Number of distinct normals which can be drawn from the point 2, 8 to the parabola y is equal to 2. Once again, just check that if h is bigger than 2a, you're done. Right? So h is 2, it is bigger than 2a, which is 3. No, it's not. So it's supposed to be one common normal. It should be the normal from. Okay, it's not necessarily this. Oh yeah, okay. Whatever. Just one normal. That's all you need to know. So 13th, this is normal 1. 14. Right. Okay, if minus 2 comma 5 and 3 comma 7 are the points of intersection of the tangents and normals, and normal at a point on parabola with the axis of the parabola. So these two are the points of intersection of the tangents and normal at a point on the parabola with the axis of the parabola. Oh, so like, okay. And the focal distance of that point is this thing. Okay. Find the value of k. Focal distance is given. Oh, huh. So from the focus you want. Interesting. But all you know is just the distance between them. That's all they have actually given us. Nothing else, right? Yeah, okay. So what is this distance though between these two? Right. So the tangent is just y equal to x plus 80 square. Whenever it intersects with the x-axis, so y equal to 0, just x equal to negative 80 square. So negative 80 square comma 0, that's the first guy. And then you got y equal to negative tx plus 280 plus you get that here. So like x is equal to 280 plus 80 cube, x is equal to 2a plus 80 square. That's the other guy, so 2a plus 80 square. Okay, this is not supposed to be happening. Right, like this. Okay, yeah. So the distance between them is just going to be like what? 2a plus 280 square, which is like 2a times 1 plus t square. And by the way, what's the focal distance? It's supposed to be x plus a. It's got 80 square plus a times of t square plus 1. That's this guy. So like 2 times the focal distance. That should be doing it. Right, that's just the distance between them, which is, square root of. So first we got what? So 3, and then you okay, like 5 squared, and then you got 2 squared, right? Yes, which is square root of 25 plus 4 is like 29. Square 29, then we go with prime number. So f must be 29, square root of 29, nothing upon. And that's supposed to be, so k is 2, I think. This is like, yeah, of course, 28 plus 1. There we go. So k must be 2, 14th, 2. Next question, 15th. Tangents are drawn from the point of the parabola, this thing, to the parabola, this thing. Okay, if the locus of midpoints of chord of contact is again a parabola. Locus of midpoints of chord of contact. Chord of contact. So, okay, so from those, okay, what's happening to my mouse? Is a parabola, once again. So, from this parabola to that parabola, okay. Boom, and then this is supposed to be again a parabola. With length of intersectum 1. Wait, no, oh, it's like L. Okay, fine. Right, I mean, basically, you're just trying to find out the locus is, right? That should be doing it. So, yeah, this curve can be parameterized, I think. Okay, cool. So, it's centered at negative 4 comma 0. It's supposed to be negative 4 plus 80 square. A is just, negative 2 right here. Yes, so negative 2t square. And then you got 280. That should do it. So that's going to be negative 4 times t, right? That's how this curve is parameterized. And so the chord of contact to this parabola, you are saying. Wait, okay, this is actually whatever, just deal with it, So what's the chord of contact going to be? Y naught is supposed to be sorry, negative 40 y naught. That's equal to, so 4x, like, okay, 2x plus 2x naught, which is 2 times of this thing, okay, minus 8 minus 4t square. Yeah, okay, why did I write y naught? So that's the chord of contact, and you want what? Locus of the midpoint of chord of contact is again oh no, the midpoint of chord of contact. That's not expected. I mean, you could just, let's just say this chord of contact is gonna pass through this thing, right? So you can actually figure out what x is, can't we? Yeah, so 4x, okay, 2x is equal to 8 plus 4t square minus 4ty. So 4x will just be equal to 16 plus 8t square minus 8ty. That's gonna be put over here. So y squared equal to that. So y squared plus 8t y, and then I'll go for this maybe whatever this constant stuff is. We don't even care about that. So the midpoint is just y mid is gonna be what, negative 4t, right? So negative b upon 2a, negative 4t. What's the x midpoint? Just use this chord once again, right? So 2x is equal to that. Basically, you're saying the x is equal to 4 plus 2t square minus 2ty. Just gonna put that over there. 4 plus 2t minus 2t times this guy is supposed to be plus 8t square, right? So it's supposed to be 4 plus 10t square, right? And I mean, they don't care about what the equation is, just care about the latest sectum length. Might as well just delete this because it's just shifting the thing, right? And might as well just inverse that. That doesn't change the geometry. So yeah, that should do it. Yeah, it's like x upon y square, or maybe just say y squared upon x, y squared upon x. That is supposed to be 16t squared upon it. Yeah, 16 upon 10. There we go. Which is like 8 upon 5. That's our latest rectum's length, right? Yeah. And you just want 5 times, so that's supposed to be 8. Next question, 16th. 16th is the equation of the line touching both the parabola, this parabola and that parabola is this guy. Then lambda is, oh, okay, so this is easy. I mean, the first guy is really easy, like y equal to mx plus a upon m, not 2a upon m, a upon m. All right, so just 1 upon m. Yeah, that should be the thing, of course, not 2a. I have this like, okay, that's nice. And it's supposed to be touching this thing as well. So this guy has x is equal to, so 1 upon m times y plus a upon m, 1 upon m, you get that. And then a in this case is just negative 8, so negative 8 upon m, so 1 upon m. Yeah, that should be the thing, of course, right? Yeah, which just means x is equal to y upon m minus 8m, which means y is equal to mx plus 8m square. So of course these must match, match up. That just means 8m cube equal to 1, so 2m equal to 1, m must be real, m equal to 1 upon 2, right? So the slope is just 1 upon 2, and we are saying, oh, so you just want to find lambda for, right? So just use this equation, x is equal to, in this case, like 2y minus lambda, or you might just say, okay, x plus 8m, sorry, minus y upon m equal to 0, so whatever. M is just 1 upon 2, is supposed to be minus 2y here, and it's supposed to be 4, so that's our lambda. So lambda is 4. Next question, 17. The shortest distance with the parabola and this parabola is this guy, then the value of the numerical quantity k must be. Shortest distance with this parabola and this parabola is this, then the numerical value of, oh, okay, doesn't matter what the geometry is, right? Okay. This is weird. I got y minus 1 right there. That's unexpected. Okay, whatever. Just shift the first guy about, right, so like x minus 1, just make that x dash, so you can just shift about 1 comma 0. Is it 1 comma 0? I don't know. Just make x minus 1 equal to x dash, and then you just have y squared equal to, and it's just a shifting, it's not changing the geometry or whatever. Y squared equal to x, and then instead of x minus 1, you're putting x everywhere, right? So instead of, like, you just put x as 1 plus x. That makes sense. So you got x plus 1 square is equal to y minus 1, right? So yeah, and you are seeing the shortest distance between this parabola and that parabola is 3 square root 2 upon k. So any point on this parabola can be parameterized, I think, which is like negative 1 plus. I'm gonna use some other kind of parameters. I just say, okay, what about k? Just use other parameterization form, so that in should we use some other parameterization or not? I mean, it could really throw off the whole thing, whatever. So this guy is parameterized like this. So minus 1 plus k right? And then y is just like 1 plus k. Oh, k square, sorry. Yeah, that should do it. Where k is of course just x plus 1. You get the idea. So, right. And then this guy just has the tangent, sorry, the normal being like y equal to negative dx plus 2. Yeah, so 2a is just, 1 upon, it's like 1 upon 2t plus 8t cubed, which is 1 upon 4t cubed, right? And you want this normal to be passing from here so that you can get the value of t and then possibly get the thing. So, wow, this is weird. So it's gonna be, why don't we just, figure out the common normal? That should be doing it, right? Yeah, okay, no need for doing all of this in that case. Just figure out the common normal. That should be, no, don't do that. It's gonna be complicated to do. Ah, this is so not good. But okay, rather than figure out the common normal, what's the best way? There's no other way. Have to do that. Just have to do that. So um, x plus 1. Oh, just use the slope instead. So y equal to mx minus m upon 2 minus m cube upon 4, right? That's this guy normal. This guy's normal is going to be different. X plus 1. So y equal to, once again just negative tx and all that stuff, right? So negative tx plus, oh, it should not be tx. Instead of x, you're going to put minus 1 over there. Plus 280. So in this case, a is of course just 1 upon 2. So plus 1 upon 2 times t. It's like that time plus t cube upon 4, right? So x plus 1 is equal to negative ty. So plus t plus that, like 3 upon 2t plus t cube upon 4. So over here, t, so yeah, okay, minus t is 1 upon m, right? More likely, like t is negative 1 upon, just put that everywhere. So it's supposed to be x plus 1 is equal to 1 upon m times y, and then minus 3 upon 2m, and then minus 1 upon 4m cube, and then just multiply by m, I think, right? Multiply by m. So you're gonna get mx plus 1, sorry, plus m in fact, is equal to y, and you got minus 3 upon 2m. Oh, that's gone, right? Yeah, and then minus 1 upon 4m squared. So y is equal to mx and all that stuff. So plus 3 upon 2 plus m plus 1 upon 4m squared. And now just need to figure out what this m is, and then you are good to go. So these must be the same. What does that mean? That just means 3 upon 2 plus 3 upon 2m. This comes here 1 upon 4m squared, and then plus m cube upon 4. That has to be equal to 0. This is scary. God, not nice, not nice. It's like 1/4 of m squared plus 1 upon, oh, it's like cube, sorry. Yeah, it's supposed to be cube, right? Okay. How do I solve this? Just, okay, maybe like just guess a solution or something. What about m equal to negative 1? Gonna work, of course, because it's gonna be a negative 1 works, right? So m equal to negative 1 is the solution. And let's just go with that because I don't want to spend more time on this thing. So there we go. You got negative 1 as the thing, right? So from here you can just figure out the point. So 80 square comma 280. A is of course 1 upon 4, and then t in this case is going to be negative 1 as well. It's like 1 upon y is going to need to dx. So okay, so it's supposed to be positive 1, right? Because yeah, minus t is m, so it has to be positive, right? So positive 1 is going to be 1/4, and you got, so 2 a is just 1 upon 2. So yeah, you don't want to like that. That's this point. What about this point? It was parameterized like, where'd that go? I don't know. Anyway, so negative 1. Oh yeah, over here like negative t has to be 1 upon m, which is also negative 1. So t has to be 1. No problem with that. So right, x plus 1, which is our y coordinate, right? Let's just be like 280. A is of course just 2a is 1 upon 2, and 2a times t is supposed to be negative 1. No, positive 1 because t is, yeah. And then y coordinate is done. X coordinate. This looks weird, right? So y minus 1 is equal to 80 squares, like 1/4, and then square doesn't matter. It's like it's only 1 in any case. So yeah, there we go. Got the thing. So x is equal to negative 1 upon 2 and y is equal to 5 upon 4. So the other guy is just negative 1 upon 2 comma 5 upon 4. Right, now we can figure out the distance. Maybe there was some other method, I don't know. So distance between these is like saying 1 upon 2 of the, just say 1 upon 4, you know. So 1 upon 4 of the distance between these 1 comma negative 2 and negative 2 comma 5, right? So it's going to be 1/4 square root of 3 square plus 7 square, I think. So that's going to be 49 plus 9, which is 58. So 1/4 square root of 58. Multiple of 4? No, multiple of 2 is there. And this is supposed to be what? Wait, where is this question? This thing, right? So 3 square root is a multiple of. It's not a multiple of 3. No, it's not. How did that come out to be a multiple of 3? It's not, right? No, it can't be. 58. But that is 7. Something must have gone wrong. This kind of question, this is like really calculated, that makes a lot of mistakes possible. Okay, so just check it once again. X plus 1 is equal to this. Okay. Y minus 1. I should be the other guy. What's going on over here? This is so not good. There must be some other way to figure out the shortest distance, right? Other than, you know, figure out normal and stuff. Check it once again, check it multiple times. First of all, replace x minus 1 by x. So basically replace x by 1 plus x. So you got this thing, and then you got x plus 1 squared is equal to y minus 1, whatever. So this guy will parameterize this thing as, you know, a is just 1/4. This is nearly bad, you know. Okay. Maybe the other parameterization would be better. So let's just say x is equal to t square, and this is supposed to be just, you know, t. The usual thing was like y is equal to negative tx plus 280 plus 80 cube. Yeah, a is just 1 upon 2 t plus 1 upon 4 t cube. That was the usual normal, right, that you used to get. But now what we have done is we have actually replaced 2t by t. So here you have to do the same, or maybe like this t by 1 upon 2t. Yeah. So then this normal would just become y equal to negative 1 upon 2 tx plus 1 upon 4 t, and then you got 1 upon 8, 32, and then t cubed. Huh? Was this nice or the worst thing to do? I have no idea. Wait, 80 square and then 280. In this case, a was just. Oh, okay, 2a was 1 upon 2. Wait, okay, so 1 upon 2t, that we got, oh, that replaced by t. So actually we replaced t by 2t, not the opposite. Oh, sorry. Then it should be y is equal to negative 2tx plus t plus, yeah, I mean, I thought this would simplify this thing, right? Because now it's a simpler form. And then this is supposed to be, you know, 2t cubed. So now we got the thing. So, yeah, right. So let's just do this once again with this new form. So this is our thing. Okay, that's our normal. So this guy has parameterization t square comma t. This will have parameters, you know, it's pretty much the same stuff, except so it's like 1 plus t square is what y will be. And this will just be, you know, t minus 1, right? Okay. This has this kind of normal, right? You might as well just, you know, right. Okay, so y is equal to, oh, it's gonna get a lot more complicated actually. Okay, let's just say t1 t1 and then t2 t2. Maybe that will make sense. Okay, cool. So sorry, this has the normal y is equal to negative 2t1 x plus t1 plus 2t1 cube. What about this guy? So y, capital Y in this case, that's going to be x plus 1 is equal to negative 2t2 times capital Y. Yeah, I mean, that's how it's supposed to be, really. So, sorry, capital X, in it's like x minus 1, and then plus t2 plus 2t2 cube, right? That should do it. Is that? Yeah, that's how it should be, right? Of course. Okay, what does that mean? It just means some clear out some stuff. So this guy just becomes y plus 2t1x is equal to t1 plus 2t1 cube. This guy becomes, so 2t2 plus x, if I go to y, plus x is equal to, so this is going to be 2t2 plus t2 plus 2t2 cubed, right? Yeah, and then you got minus 1. Is that right? It's supposed to be just 3t1. Sorry, it's supposed to be t2. What am I doing? Plus 2t2 cubed minus 1. So what must happen is that, just take the ratio, is supposed to be 1 upon 2t2 is equal to 2t1 is equal to the ratio of these, which is t1 cubed plus 2t1 cubed upon, yeah, okay, this is not efficient. I need some other way that would be more efficient, Isn't there some other way that's more efficient than this thing? Just figure out the shortest string, the parabolas like that, without actually having to do anything. I wish there was. What about, okay, what about, instead of doing all of this, just, figure out the square distance between these things. That's, I think maybe that's better. So, and then just take the partial derivative, and that is something we can do instead of doing all of this. Yeah. So once you have this parameterized, just figure out the distance. Why even do all of this? I mean, you just care about the distance. So the distance square is supposed to be t1 square minus, so like plus 1 minus t2, that guy square, plus t2 square minus t1 plus 1 squared, right? So you want to maximize this thing. Just take a partial derivative with respect to t2 first. So it's going to be 2 times of all of this. Oh, it's supposed to be negative right here. Okay. So t1 square plus 1 minus t2, whatever. And then that thing, oh, this is also having t2. So, okay. 2, 2, 4, 4 t2, and then you got t2 square minus t1 plus 1, right? Of course, that has to be equal to 0. Okay, cool. And similarly, you can do something with t1. So just taking a partial derivative of t1, you got 4 t1 times all of this. So t1 square plus 1 minus t2, and then derivative of that thing, like got 2 over there. It's supposed to be minus right there. So minus 2t1, and then you got t2 square minus t1 plus 1 is equal to 0, right? So doesn't this look much simpler than the last thing we did? Yeah. And then this thing is also just 4, so 2t1, and then you got t1 square plus 1 minus t2 is equal to, so it's supposed to be just t1 times all of this, t2 square minus t1 plus 1, right? I mean, still it's kind of complicated because we don't exactly know what's going on. Right, there must be some other thing that you can do. So we want to maximize this guy, and t1 t2 are just like random. We don't care about what they actually are. Yeah. Okay, now what? Now that we are at this stage, we're kind of stuck, aren't we? You have to figure out what t2 t1 are. Other than that, you have no other way to do it. But how do we do that? It's gonna be some kind of cubic or something. Let's take that. Oh, why did I put that on this? Yeah, this is supposed to be it. It's supposed to be 2t1 just over here. So you can of course take the ratio. That's like saying 4t1 t2 is equal to 1, right? That's one thing. What else can you do? Right, I mean, you just need to figure out what this thing is what else can you do? You have to solve one of these equations. So 2t2 cube minus 2t1t2 plus 2t2 is equal to t1 square plus 1 minus t2, right? So 2t2 cube minus, oh, and t2 t1 is just 1 upon 4, so minus 1 upon 2 plus, and then this is supposed to be equals 3t2 is equal to t1 square plus 1, right? But then t1, remember, it's just 1 upon 4 t2, so it's supposed to be 1 upon, I don't know, something like, yeah, 16 t2 square plus 1. I should have used some other variable other than t1 t2, but yeah, whatever, it works. Okay, I think this is a nice method. So yeah, right, okay, this now is our equation, is multiplied by 16t2 square. Suppose, man, it's gonna be what? Okay, no, that's not right. It's gonna be fifth degree. How can I even solve a fifth degree equation? That's just impossible, right? So now what? Okay, maybe you should just guess out a solution or something from this equation. This is looking bad. This is looking really bad. Yeah, okay, this at this point we're stuck. How can we proceed further? I'm supposed to square from. How do you proceed further, right? I don't know. I don't know. This is, okay, we should just leave this because it's a fifth degree equation. There's no way we can actually solve this, can we? We just, let's just guess something. What about t1 is equal to 1 upon 2, t2 equal to 1 upon 2? Does that solve this? So this is a 1 upon 2. That's going to be, 1 upon 4 minus 1 upon 2 plus 3 upon 2. That should be equal to 1 upon 4 plus 1. Hey, that is the solution. Okay, so that's the solution for this thing, I guess. I mean, yeah, it satisfies this equation, it also satisfies this equation, so it also satisfies both of these equations, right? So that's nice, right? So 1 upon 2, 1 upon 2 is the solution. That just means, okay, now we can just figure out what this distance is actually. Hey, so just have to guess. Oh, that's not good. We can't be guessing all the time. What if they give us something that's actually not solvable? Anyway, 1 upon 2, 1 upon 2 is the solution for this thing. So 1 upon 4 plus 1 minus 1 upon 2. This guy square, and they got 1 upon 4 minus 1 upon 2 plus 1. This guy square. So basically 1 upon 2 plus 1 upon 4, right? Which is 3 upon 4 squared. Sorry. Plus 1 upon 2, 3 upon 4 squared. Okay. Which is, just 3/4 square root of 2. I mean, square root of that, which is 3/4 square root of 2. So k must be 4. But this is, I don't like this. It's basically just guesswork. We have to form this equation. Yeah, just guess out the solutions. Fine. Next question. And I mean, in the end, it's a fifth degree equation. It's going to be so many different solutions for this thing. How can you just get a solution? I don't know. So, okay, so let's just go to the next question, which is, wait, that was 16th, right? 16th was 17th is, wait, 18th was for, wait, did I not do this thing? Oh, okay, I didn't do 17th. 18th is 4th. What about 17th? S is the focus of the parabola PQ. And okay, so parabola and PQ be a focal chord, and SP, SQ are the roots of this equation, right? Okay, that's not solvable. This equation is not solvable. Okay, fine. And L be the distance between the focus and the directrix. What even L is? Oh, okay. Focal chord. The only thing we know is like t1 times t2 is equal to -1. And then these distances are going to be 8 times of t1 plus t1 square, 8 times of 1 plus t2 square. So the sum of these distances, we know that thing. What about, we also know the product of these distances. Maybe we can do it. Maybe we can do it. Let's figure out. So 2 plus t1 square plus t2 square, that's the sum of distances. It's just going to equal to 7 upon 2, right? Okay, and then the product is going to be 1 plus t1 square plus t2 square. Oh, and t1, t2, that thing square is just goes 2. So, wait, what? How can that be? Oh, that's that a thing. Oh, sorry. There's supposed to be a times of all that. And this must be, you know, a square times all of that. Oh, that was actually easier than expected. That is equal to 1 upon 2. Just divide these things. A is equal to 1 upon 7, I think. So that's okay. And we want L be the distance between the focus and the directrix. That's going to be 2 upon 7. So 21 L. That's 6, right? So 17th 6. Next question. 19. The shortest distance between the parabola, this parabola, and that parabola is this guy. Oh, we did this. Sorry. 19th. If the focal distance of y squared equals 16x is tangent to the circle, focal chord of this thing is tangent to that circle, okay, then the positive value of the slope of the chord is what? Positive value of the slope of the chord. Oh, okay, so absolute value. That's fine. So focal chord is tangent to this circle. Okay, what's the focal chord? I mean, that slope is supposed to be just 1 upon t1 plus t2, right? Yeah, okay, so t1 times t2 is equal to -1, and then slope is 1 upon, and it's like going to be y is equal to 0 plus m, which is sorry, 2 upon t1 plus t2, that thing, and that times of x minus x naught, which is x naught is just going to be a in this case, right? Okay, understandable. And oh, so a is 4 in this case, right? This is the tangent to this circle. Wait, okay, why are we doing all of this? It's like saying the tangent to this circle passes through the focus. Oh, we didn't actually have to do all of this. So what's the tangent to the circle? It's just going to be y is equal to mx plus, oh, and by the way, instead of x, you actually have to do x minus shifted. Okay, plus minus r. R is just going to be, oh, square root of 2. Okay, square root of 2 times of, and then you got m squared plus 1, right? That's the thing. So that's the tangent, and it passes through the focus, which is 4 comma 0, right? So 0 is equal to m times minus 2m plus or minus square root of 2 times of m squared plus 1. So that's going to be like square root of m squared plus 1 is equal to square root of 2 times absolute value of m. Square that, m squared plus 1, okay, that comes out. So m squared plus 1 is equal to 2m squared. So m squared must be 1. M has to be plus or minus 1. Absolute value 1. So 19, 1. Next question, 20. The complete value of alpha for which the point -2 alpha, alpha plus 1 is in the interior of the smaller region bounded by the x squared plus y squared to 4 and y squared to 4x. So this is at 1 comma 0, and this is like, okay, it's radius of 2 or something. Okay, so the smaller region, you mean this region, right? Okay, we want this point to be inside of this region, right? Of course. So then it must be inside the circle, it must be inside the parabola, basically. Okay, right, so just do this thing. So inside being it being inside circle, that just means x squared is like 4 alpha squared plus y squared is like alpha squared plus 2 alpha plus 1. This must be less than or equal to 4. So 5 alpha squared plus 2 alpha minus 3, right? That has to be less than or equal to 0. So -15. Oh, okay, you can split it like that. 5 alpha squared plus 5 alpha minus 3 alpha minus 3 is less than or equal to 0. Alpha plus 1, then you got 5 alpha, so like basically alpha minus 3 upon 5 is less than or equal to 0. Alpha belongs to negative 1 to 3 upon 5. Should be inclusive, I think. Yeah, or whatever, don't include that. Doesn't really matter in the end. Okay, and also it should be inside this parabola, so y squared minus 4x must be less than 0 because yeah, right, if y is more than expected, right, it should be less than 0, right? Not bigger than 0, less than 0, right? So y was just that guy, right? Alpha plus 1, that gets squared. So alpha squared plus 2 alpha plus 1, that must be less than 4x, which is 4 times of this guy. Oh, weird. Okay, well, whatever. This is unexpected. So like minus 4 alpha. Sorry, 4 times of what am I doing? Minus 8 alpha. Fine. This is not good looking good, Okay, so 10 alpha plus 1 is just 1, 0. Okay. So at negative 5, you will get the minimum value, right? What are the roots of this? Oh God, it's less than 0, so it should be between the roots. Just figure out the smaller root, so minus 10 plus square root of b square minus 2. Oh, it's gonna be large. It's gonna be really large. 100 minus 4 is minus 4. Okay, all of that upon 2. So minus 5 minus square root of, so 25 minus 1, I think it's just 24, right? So basically minus, okay, approximately minus 10. And the other root will be, minus 5 plus square root of 24. Wait, so both of these are just negative, huh? That's weird. Oh, that's to be expected because sum is negative and product is positive. Both are just negative. This is the bigger root, and right, it's less than 0, so like it lies in this range between these, and it also lies in this range. Okay, so it has to be negative 1. This is of course bigger than magnitude wise is bigger than 1, right? So negative 1 to this guy because I looks like it's smaller than, yeah, of course it is 1 upon square root of 25 plus 20 plus 20. Yeah, right. So that's right. Sort of 24 minus 5, of course. Okay, we just write it like that. Minus 5 plus 24. That's the thing. Okay, that's our range. So, right. Okay, you get the idea that A is just 1. C is 5. And then this thing is 2 square root of 6, right? So B must be 2. We want A plus B plus C, which is 8. Next question. Next is 21. If the point h comma k on the line x plus y equal to 4 is nearest to the parabola y squared equal to 4 times of x minus 9, then h plus k is. This point on this line is nearest to this parabola. Okay. Plus y equal to 4. It's nearest to this parabola. Okay, so what's the parameterization of this? It's going to be like 4 times of that or something. Fine, x is going to be 9 plus 80 square, a is just 1, so like plus t square, and this is going to be 280, which is 2 times of t. That's the parameterization, and you want some point on this line to be nearest to this parabola. Okay. That's weird. Then h plus k is what? Okay. Wait, why am I doing? Look, this point is just on this line, right? Oh god, this point is on this line, and then you're asking h plus what is this? It's equal to 4. We can say that blindly without actually doing the question. Why did we even? Okay, I guess it's supposed to be h minus or something like that, but If it's s plus k, we already know that's supposed to be 4. So what was the point of this question? I mean, the second part didn't even, like, it was not even necessary. 22nd. Two parabolae are confocal and have the coordinate axis as directrix. Okay. Coordinate axis as the directrix. Oh, so first has like x-axis and second has y-axis. If AB are their common chord, oh, so confocal, like, like so. Okay, wait, so their focus might be, I don't know, somewhere over here. That might be the common focus. It's got these as the directrices, right? And they're talking about what? AB is their common chord. Which common chord? Oh, sum of all possible slopes. Okay, okay, okay. Now I understand what's going on. Huh. Understandable. Some of the of all the possible slopes. Hmm. Let's just use a different thing. I mean, we just want the slopes, right? It doesn't matter if we shift the thing. So might as well take this parabola. So y is equal to 4x. Wait, what question is this? 22, right? Yeah. So wait. Okay. Y is equal to 4ax. And you got the focus over here, e comma 0, and you got some other uh, parabola like this. I don't know. It has directs over here, right? So the it's gonna be like y is equal to minus 2b or something. So y equal to b is the tangent at the vertex minus b. Yeah. Right. So this is the parabola that we're looking for, which is of course right. So it's got just like this guy. Okay. Your coordinate along the axis of this parabola is the y coordinate, and it's centered at, so this is the focus of this guy. It's centered at what? Centered at a comma negative b, right? So y plus b, no, that's b, that's along the x, right? So y plus b, then you got 4b, because of course this has b as the thing, okay? And you got x minus a, right? So a squared is equal to this guy. That's the thing. Yes, yes. Okay, so that's the other parabola. So some point on this thing, 80 square comma 280, if this lies on this parabola, right? Then what exactly is going on? That just means, okay, 80 square, okay, minus 1, but it's like a squared times t square minus 1 squared is equal to 4b times 1 plus, oh yeah, like 280 plus b. I guess we will have to expand. There's no other choice. So a square t power 4 minus, and by the way, it's only like 4 such points, right? Yes. Okay, so a square t power 4. And okay, we want the sum of the what? Sum of all possibles, and each slope is of the form 2 upon ti plus tj, right? So we want some of those kind of things. That's weird. All possible slopes. Uh-oh. That isn't looking good. That isn't looking good. Oh no. I mean, you can figure out what T1, T2, T3, I mean, some of them or like product of them or something like that, but some of these kind of things, 1 upon T1 plus T2. Okay, how do we do that? I don't have any idea on this thing. All of this thing. Okay, just keep on doing it. It will get something nice. Okay. Minus. No, I don't think we're gonna get anything nice now. First of all, okay, let's divide by a square. This will be t power 4 minus 2t square plus 1 is equal to 8b upon a times t, and then it's supposed to be plus 4b square upon a square. So t power, there's no cube term, that's important, minus 2t. Oh, and this is kind of constant. Nice. Right, okay, minus 8b upon a times t, and then plus 1 minus 4b squared upon, we don't really know what this is. I mean, like, these terms we don't know. What we do know is that summation of ti is just equal to 0, and summation of ti tj, right? So all 4 of them, right? That's equal to 2. Sorry, minus 2, I think. Yeah. Okay, and from here we want to figure out what's the summation of 1 upon ti plus tj. Oh no, we want the, yeah, okay, that is in fact the slope. Sorry, 2 of that. Right. How do you get that slope? Okay, how do you get this expression? Uh, Come on, think about it. Ti tj is equal to such a ti is 0. Wait a second. 2 upon t1 plus t2, and then you got plus. I mean, yeah, just make all 6 matches, of course. So t1 plus, I don't know, t3, and then you got plus 2 upon t1 plus t4, and then plus 2 upon t2 plus t3 plus 2 upon t2 plus t4, okay, plus 2 upon t3 plus t4, right? All of these matches. What I'm thinking is, okay, t1 plus t2 is just negative of t3 plus t4, so that t3 plus t4, and okay, these terms we can just cancel them out, no worries. What about these? Okay, t1 t3 need to have t2 t4 somehow, so you got this thing, this should cancel out as well. And then like, okay, all 6 matches will have their opposites somewhere, so this just becomes 0. The sum of the slope is just equal to 0. Nice, I think. Next, 23. The area enclosed by the common tangents to this thing and this thing, and the chords of contact is k squared and mod of k. What's no? It's like the greatest integer function of k, I think. Okay. Area enclosed by common tangents to this thing, circle, and this thing. Okay. Common tangents. So why should we do 4ax like this thing? You got at a comma 0, just have the focus, and then this is like, okay, a upon square root 2 is the, yeah, so a upon square root 2 is less than a, it's gonna be over here or something, and you want the area enclosed by the common tangents. So there's only 2 such common tangents, right? Like this, like that, and they're chord of contact. So this thing, right? That area is ka square, then k equals. What does it look like? I've seen this. Oh yeah. So look, right. I think I made a video on this thing as well. Like, what is the, no, no, I just made a video on what the circle. So right, the circle of this thing. Okay, we can figure that out. That's not what we want. We want the area, right? Okay. Okay. Right. Yeah, just, I mean, figure out tangents. That should do it. So tangent is like y is equal to x plus 80 square. This thing is a tangent to this circle, 0, 0 centered. It's got 80 square upon square root of t square plus 1. Right? This distance has to be equal to square root of this, like, okay, a upon square root 2. A cancels, just get 2t power 4 is equal to t square plus 1. Right? So basically 1 plus t square minus 2t power 4 is equal to 0, which means 1 plus 2t square, and then got 1 minus t square, I think. That's equal to 0, right? Yeah. So this cannot be 0. T square has to be 1. That's the only way. So t equal to plus minus 1, right? And when does this actually intersect with the x-axis? That will happen when y is 0, just x equal to negative 80 square. So a is, we don't know what that is, but t is 1. It has to be negative a right there. Oh, that's on the directrix. It's passing through focus. Oh, this is passing through focus, huh? Amazing. I mean, yeah, like, what's the x coordinate? X coordinate is supposed to be a. So, it's passing through focus. Perfect. Okay, and you just want, so like, this is going to be 90 degrees right there. Doesn't really matter. I mean, we just found out this distance, that's enough. It's going to be 2a right here, it's going to be a. So half of 2 of was 2 times of this time. Yeah, and then you got, this is like 2a, and this is also 2a. So, yes, cancels 4a squared. K is supposed to be 4. The greatest integer function of that, still 4, no big deal. Next question. the two parabolas y squared equal to 4ax and y squared equal to 4 times of a minus 1 times x minus b cannot have common normal other than x's unless b is bigger than lambda, then find lambda. Okay, this parabola and this parabola, these two cannot have common normal. Ooh. Interesting. A minus 1. Okay, so for them to have a common normal, what's the condition, right? Think. Well, whatever the normal is, it's gonna like pass through some point on the axis, right? Huh. Yeah, right. Okay. Common normal. What is that? I mean, okay, we don't have another choice. We just have to do it the usual way. So the first guy is first guy normal is just y is equal to mx minus 2am minus am cubed. Second guy, same stuff except that just have a minus 1 replacing a and x minus b replacing x. So mx minus bm minus 2 times of like a minus 1, so minus 2am, and then this minus 1 plus 1 is like plus, so plus 2 times m. Okay, minus am cubed, once again a is replaced by a minus 1, right? So minus am cubed and plus m cubed, right? These two are the common normals. Of course, that just means these must be the same, right? So bm has to be equal to right, okay, this cancels, cool, and then this cancels, perfect. Bm is just equal to, right, I mean these two have to be the same, then okay, this thing, okay, that has to be 0, okay, fine. So bm is equal to 2m plus m cubed. M could be 0, that's one thing, right? I mean that's definitely common norm. Wait, what? But oh, that just means they can always have common normal. That's oh, other than x is of course. So like x is for that m is equal to 0. So this part b is equal to 2 plus m cubed. Sorry, m squared. That's the other thing. So b has to be bigger than 2, right? Or equal to 2. If it's equal to 2, then what does that? What does that mean? I don't know. Okay. So lambda is 2, of course. We know that. Next question. Oh yeah, if it's equal to 2, then m is equal to 0. So it's still the axis. It has to be bigger than 2. Strictly bigger than 2. So what had I do? Next question, 25th. P is a point on the parabola. PQ is perpendicular to D. PQ is this thing, it's perpendicular to D. D? What's D? What is D? What do you mean by that? This is, oh, it's a directrix. Okay. And F is the focus. Okay. So PQ is perpendicular to directrix. Fine. F is the focus. If triangle PQF is equilateral, its area is this thing, and K equals. So look, this angle is 60 degrees. This angle is also 60 degrees because like parallel. So this is going to be 60 degrees right there. Yeah. Oh, hey, okay. This is actually very easy because we can directly figure out what this distance must be, right? Yeah, right. So, yeah, right. This is this distance. I'm just going to draw this. So this is A. This we don't know what this is like. Just call it R or S or whatever you want. We know that this is also like R. This is 60 degrees right there. So this has to be R upon 2. That means this has to be R upon this has to be R upon 2. R upon 2 is equal to A. R equal to 2A. Easy as that. Yes. Yeah, I mean, I think that makes sense. Right. So once you know that, it's just 2A like that. So what's the area? So 3 upon 4 times 2A squared. Right? Yeah, that is the area, of course. Right, that makes sense. So just got 4A squared. Cancel. So 3A squared, that's the answer. Okay. So yeah, like K has to be 1. Makes sense? I think it does. The length of lattice rectum is 4A. Okay, fine. As usual, no big deal. Shit, no, this has to be 2A. Okay, this has to be the focus and the direct. It's not the focus in the. This has to be 2A. This has to be 4A in that case. So actually, you're doing 4a square, which is like 16a square. So k has to be 4, not 1. There we go. 25th 4. Next 26th. A variable complex number z satisfying z plus z conjugate real of z is equal to 2 times of magnitude of z minus 1. So the x coordinate of this z, right? Basically like the distance from the y coordinate. Yeah, okay, we know it's supposed to be parabola and everything. Yeah, oh, that's sorry, 2 times the real of z coordinate, right? 2 times of real of z. That's equal to this. So real of z is equal to just magnitude of z minus 1. So 1 is the focus and this thing is the, yeah, the y is just the directrix. Z1 Z2 are complex numbers on the curve described by z in the argument plane such that argument of z1 minus z2 is equal to pi upon 4. So, okay, the angle between them is like, fine, no big deal. Just subtends angle pi upon 4 on this, right, center of the, it's not a center anymore, it's a directrix, right? This has to be pi upon 4 or something. Okay. I mean, if it was like pi upon 2, it would be awesome, but it's not. Evaluate, what is this? Imaginary of z1 plus z2. Okay, fine. Wait. Z1 minus z2. Okay, this is different. Complex number on diagram. Wait, what diagram? What do you mean? I don't see any diagram. Oh, so both of these satisfy this relation, and okay, and then z1 and z2 just like that. Okay, fine. Oh, it doesn't mean like that. It doesn't mean anything like that. It's the slope, right? The slope is tan of pi upon 4 is going to be 1. That's what it's saying. So you got this parabola, whatever. It's drawing really bad. Something like this. I don't know. Okay, it's supposed to be over here actually. This, whatever. The thing is, you've got two points over here. So the vector going from z1 to z2, let's say this thing z1. So z2 1 to z2, that vector makes angle pi upon 4 with the axis. That's all it really means, right? So yeah, okay, cool. So like 2 upon t1 plus t2. If you just take these as the actual coordinate axis, although we're not doing that. Oh, okay, you actually have to do that now. So then this is parameterized as actually parameterized as this is like what, this is 1, this has to be 1 upon 2, right? Okay, so x coordinate you already have this 1 upon 2, and then you got at squared, right? A is 1 upon 2, so 1 upon 2 t squared comma 2at is just t. Yeah, that's the thing, right? And this slope is once again just 2 upon t1 plus t2. That's equal to 1. So t1 plus t2 is equal to 2, right? So the imaginary parts, of course, the sum of them is like 2. That's going to be 2. Yeah, this is the answer. So 26th 2. Next, 27. P is a variable point on the circle. Q is a variable point on this parabola. If the minimum value of PQ mod of it is a squared pi minus 1, then A is. So any point in the circle, Q is a variable point on the parabola. Okay. Minimum value of PQ is, oh, so it's like, fine. So normal must pass through this thing. Right? It's actually doable. So, the thing, y is equal to negative tx plus 2 plus 8t. A is 1 in this case, right? So plus t plus 8. 2, sorry. Yeah, and this should pass through this guy, 2 comma 8, right? So 8 is equal to negative 2t plus 2t plus t cube. That means t has to be 2, which means our point is just, so point q is just, so t equal to 2. That just means 4 over here, and we got t square is 54 once again, right? And p is any point. Okay, I get that. PQ minimum value, of course. P is just, right? I mean, we know that it's just the distance from Q to center minus the radius. So that's going to be square root of 2 square plus, because that's 2 comma 8, so 2 square plus 4 square, and this thing minus the radius, which is 1. There we go. This should just be 2 square root of 1 plus, yeah, like 5 minus 1. So A is 2. Next, so to 28 now. Equilateral triangle of side lengths. What? Oh, it's over here. 1, 3, 5 are placed end to end on the x-axis. So this is 1. This thing is 3. This thing is 5. Hey, you know what? Like the sum of the first odd, the first, let's just say n odd numbers. That's supposed to be what? It's supposed to be the square, right? Yeah. Okay. Show that the vertices A1, A2, A3, right? These vertices lie on a parabola. What is the distance of vertex A100 from the directrix? Right, okay, it's doable, I think. And it's not that bad. Just need to figure out what the sequence is behaving like. Okay, yeah, of course. So, okay, it's halved. It's half, not, huh. This is unexpected. Right. These are supposed to be lying on a parabola. Fine, just figure out what AN is. So what's the X coordinate? What's the Y coordinate of this guy? You need to figure out what that thing is. Okay, so for the first guy, I just figure out the X coordinate first. You know, what is Y coordinate? First guy has Y coordinate. So side lengths are given, right? First guy will have Y coordinate. So what? How do you parameterize the side lengths? Like 2n minus 1? No, plus 1. No, minus 1 is correct. Because n equal to 1 just means 1 and then 3 and so on, right? So the okay, the height of these triangles is just going to be square root 3 upon 2 times. No, yeah, square root 3 upon 2 times this guy. So the Y coordinate we already know. Y is just square root 3 upon 2 times this guy. Yeah. Okay, nice. What about the X coordinate? X coordinate is trickier, right? So 1 till n minus 1, all triangles have been there already. So n minus 1 squared is already there. And now you need to add half of this other side length that you have. So n minus 1 thing, right? Yeah, okay. You just have to add that as well. Half of that's like n minus 1 upon 2. That's the thing. So you got X, you got Y. Nice. 2n minus 1 or something. And what do you want? You also want the distance of 100 from the directrix. Let me just figure out these things. Oh, from the directrix, just like that, not anything else. Just find x, and oh, you also need to figure out the k values. So you actually have to figure out the thing. Okay, let's do it. So, what does this mean? Y plus 1 upon 2, sorry, plus square root 3 upon 2 is equal to square root 3 times n, and x, so n square minus 2n, n square minus 2n, and shit, plus 1, got plus n somehow, and then minus 1 upon 2, n square minus n plus 1 upon 2, which is n minus 1 upon 2 square, plus, am I going correct? It must be, right? Plus 1 upon 4. So x is, should, just like, okay, x minus 1 upon 4, that is just n minus 1 upon 2 square. We need n minus 1 upon 2 over here as well. So once you do that, you also have to add some stuff over there. Oh, we already had n minus 1 upon 2. Why do you, okay, so, right. This is already like that. Nice. So, right, y square is just 3 times of x minus 1 upon 4. That should do it, right? So what's the directrix? Directrix, of course, is x minus 1 upon 4 is equal to minus a, which is minus 3 upon 4. 4a. So, yeah. Yeah, this should make sense. So x is equal to minus 2.4, so like minus 1 upon 2. That's the x coordinate, right, of the directrix. Okay, so you just want the distance of 100 from that. Yeah, of course. So 1 upon 2 plus all of this stuff. Okay, it's going to be n plus n minus 1 square. It's like, okay, 100 plus 99 square. What? Oh, I don't like this thing. It should be a huge number. Okay. It's supposed to be 100 plus 100 minus 1 square. Or you can just use this thing alternatively, right? Yeah. Whatever, just keep going. We'll get somewhere, right? 100 square. I'm thinking this thing is like better. So 100 and then you got this times 99 and then plus 1 upon 2, but you got plus 1 upon 2 once again. So just plus 1. So 9900, but plus 1, so 9901, I think. Okay. What you want, you just have to show that that's a proof question. It's not supposed to be, whatever. So what's the distance of vertex A? Just want to write out the whole thing. So the parabola is just, y, where did that go? Y square is equal to 3 times of x minus 1 upon 4. And what is the distance? So OA 100. Wait, no, you just want directrix, right? Yeah. DA 100 is, this is just like 901. Hopefully it's correct. Most likely it's not because calculation errors. Whatever, next question, 29. Normals are drawn from the point. How much is left? Just 8 more questions. Keep going. Normals are drawn from the point P to the, what's the time? 11:06. Fine. And the thing is, like, I have a test in few hours, so do this quick. Normals are drawn from point P to the parabola. If 2 of the 3 normals drawn to y squared to 32x are at right angles. So normals at right angles, tangents are also at right angles. Okay. The parabola, okay. 2 of the 3 normals. So, okay, like T1, T2 is equal to -1, and then these are just 3 normals. Fine. Locus of point P is a conic. Oh, this is unexpected. T1 times T2 is equal to -1. Wait, what? Oh, sorry. So, 3 normals drawn to. But that's different. It's 2x over here, it's 32x over here. Are at right angles. From where? From where are you drawing normals to? Are you drawing normals to this thing or that thing? I think it's supposed to be 32 on both times, but here they have 2x. What? I don't understand what this question is saying. Normals are drawn from point P to this parabola. Okay, cool. And then what? If 2 of the 3 normals drawn to parabola, this is different. This is not that parabola. So with some other parabola to which you are drawing 3 normals, and those have 2 normals being at right angles. Fine. And then you're talking about P, but you don't know where from where these 3 normals are actually being generated. So assume it's from P, but that would mean normals are being drawn from this as well as that. So it's like common normals or something. But then it's also 3 normals. What is this? This is not good. X. Common normals of these guys. Seriously. This guy is a common normal of, so y is equal to mx plus, sorry, that's the tangent. I don't want the normal. Mx minus 2am. So minus, and then 2a is just, of course, just 1. So minus 1 times m. Plus am cubed. So, sorry, minus am cubed. So just minus 1 upon 2m cubed. This guy has a common normal of y is equal to mx minus 2am, which is minus 2a is just 16, so like minus 16m. It's am cubed minus 8m cubed. These must be the same. That's what you're saying? Really? Okay, that's like saying 2m plus m cubed is in fact equal to 32m plus 16m cubed, which means either m is 0, which we'll ignore. Another guy which is just 2 plus m square is equal to 32 plus 16m square, which means 15m square is equal to minus 30, so m is equal to minus 2. Sorry, m squared. Wait, what? That makes no sense, of course. Yeah. This makes no sense, right? Yep. It's saying that, yeah, okay, this is not making any sense. So there's only one normal, common normal for these two parabola. I don't know, this makes no sense. This question is just written really bad, I think. Anyway, 30 question. These can't have common normals. except of course, I mean, of course, this cannot have. Yeah, no way. There's no way. That's not possible. I think the question is like the normals are supposed to be to 32, so y is equal to 32x both of the times, but there's a misprint and just 2x over here. It should, I think, be 32x, right? Okay, so I'm gonna assume this was 32x as well, and then I'm gonna solve this. Right, so you are saying T1, T2 is equal to -1, and the normal drawns are like, okay. Huh. And then P, so this is weird, isn't it? Yeah, T1, T2 is just -1. What does that tell us? I don't know. What's the thing? So y is equal to -tx plus 280 plus 80. Just say h comma k. I don't know. Just gonna use y and stuff. Plus 280 plus 80 cubed. There are three such p values that will satisfy this. It's like 80 cubed. Just divide by that. No one really cares. T cubed plus 2t minus x upon a times t. Okay, and minus y upon a is equal to 0, right? Oops. Okay, it's like 2 minus x upon a times t. Right, so t1 plus t2 plus t3 is equal to 0, no big deal. Summation of t is equal to 0. Then you got summation of t1, t2, that's equal to 2 minus x upon a, and then summation of t, so like product t1, t2, t3. That's just equal to minus y upon, sorry, plus y upon, because, yeah. But the thing is, t1, t2 is just -1, so like t3 is supposed to be equal to -y upon a, just gonna put that everywhere, right? So t1 plus t2 is in fact just, y upon a. Okay, that's important. And what about this guy? So t1, t2, and then t2, t3. T2 is like just -1, we already know that. Plus t2, t3, and so t3 times t2 plus t1, right? Which is y upon a times t3 is just negative. Yeah, that is equal to 2 minus x upon a. Hey, that's it. You got the locus. So, right, just 1 plus y squared upon a squared is equal to x upon a minus 2. Right, so minus 3 right there. So y squared is just equal to a times of x minus 3a. That should be the thing. Cool. So that's the locus. Right, so P is a conic on a conic. Find the latest vector of the conic. A, right? In this case, A was 8. So that is the answer. Next question, 30. Let L1 x plus y equal to 0 and L2 x minus y equal to 0 are tangents of parabola whose focus is S1, 2. Okay. These two are tangents to a parabola. Oh, the slope are just 1 and -1. Wait, what? Y equal to minus x and y equal to x? Oh, focus is okay, fine. Huh. But then it's a perpendicular. We know where. Oh, okay. Starting to make sense somewhat. If the length of theta rectum of the parabola can be expressed as this thing, okay, find the value of m plus n. Huh. Think about this. These two are like tangents. Why would that be the thing? Passing through that. I mean, you know where these intersect, right? Okay. That's the directrix and everything. Focus is 1, 2. It's just some kind of random point. And these are like, these are tangents, right? That's the important thing. These are tangents. So that's not important. Come on, think about it. I mean, you can figure out the distance point. You can figure out passing through the directrix and everything. Okay, no big deal. But then, how do we actually figure out this distance and everything? This is crazy, right? The normals are supposed to be also perpendicular. Okay, that's not important. Just got some. So think about it. You got two random tangents, a random focus, intersecting somewhere. We don't know where, right? It might be that the point is over here or over here. We don't know. Okay. Right. So depending on these lengths, we can actually figure out what the directrix should be like. It's supposed to be the same length. So something like this, something like that, and then it's passed through that. Weird, isn't it? Yeah, it's weird. Think about it. Thing is, like, this is not even perpendicular directrix. Directrix might be, I don't know, something like this thing. Doesn't really matter. Okay. Go on, think about this. Think about this. What can we do so that this would be, doable somehow? Same angle and everything, and things that we can find out are, these distances. Okay, so you can figure out these distances. No big deal. How is that even helpful? It's not. Why would that be helpful? Go on, think about it. Yeah, think about it. This angle is theta. This angle is also just theta. This is we don't know what this angle is. Shit. That's 90 degree right there. Something. I don't know. I don't know what to do about this now. I mean, the directrix would be anywhere. How do we know for sure that? I mean, just given the tangents and the focus, can you actually figure out everything? I don't know. These are perpendicular, yes, but other than that, what do we even know? Nothing. We know where this intersect, yes. We know where the focus is, okay, no problem. Other than that, what do we know? We know nothing. Huh. We don't know what directrix orientation is. It could be anything. What do you want? Length of its rectum of the parabola can be expressed as this thing. Okay. No. Let's draw out this thing and okay. These two lengths must be the same. I think that's important that these two lengths must be the same, right? So I mean, yeah, like these angles must be the same. These angles must be the same. Okay, fine. Okay, what else? What else do we know about this? Oh well, this is like perpendicular directrix. Hey, so you got this directrix. We don't know what's happening to it. You got some point on that. You got these perpendicular tangents. It's gonna provide really bad so that it's more and more general. Some focus, we don't know where it is, right? Just some focus somewhere. Right. Okay. So there's a line going through this focus. It's gonna intersect at these 2 points. What do we know? We know that if we draw perpendiculars from these two lines, right, these angles must be the same. These angles are the same. These lengths are also the same, right? That's some angle, right? It's like that's perpendicular to that. Okay. This is the same length, but we don't know if it's perpendicular to that. Hey, what if I construct a perpendicular? So what if, like, okay, I just say perpendicular to this thing and what do we know? Is this actually really perpendicular? No, it's not. Not necessarily, is it? No, not necessarily, right? So, for example, right, okay, like what do we know? This slope is just 2 upon t1 plus t2. What is this slope? It's gonna intersect somewhere over here. We know where it intersects. It's like it's gonna be so a times of t1 t2, which is this negative a, and then you got a times of t1 plus t2, right? Okay, and you gotta find this slope. So a times of t1 plus t2 minus 0. So yeah, the focus is like a comma 0. Okay, that thing upon negative a minus, oh, this is wow, that's like nice. Okay, look, this times that is just negative. Hey, this is perpendicular to that. Oh, awesome. Huh, I didn't even know what is that. This is actually the perpendicular. Okay, it's the feet of perpendicular from this point. Crazy, right? Okay, what does that mean? Uh, hey, that means you just need to drop the perpendicular from this point onto the. I was like, just okay, you know how to construct this perpendicular. That's no problem. And then you're just gonna construct a line like that, and boom, you got these 2 points, right? And then you can figure out their midpoint, and so their midpoint is like, okay, this, yeah, their midpoint and this point, they are both going to be on the same level, you can say. I mean, yeah, they are. I mean, this line is specifically perpendicular to, sorry, parallel to the axis. And then once you know that, you can figure out directrix. Cool. And then you will have everything. Oh, so that's how you do it, huh? Nice, I guess. Yeah, that's awesome. Really nice. Okay, cool. You don't exactly know what these points are. All you know is just these two lines, basically. You're gonna draw perpendicular to the focus. Okay, cool. Uh, yeah, but I mean, you have to do the thing. You have to do it completely. Let's just do it now. Nice question. I mean, makes you think about it. That just with this much of information, how can you do everything? Yes, you can actually. Okay, so now let's do it. This point, they already told us. So it's like, okay, that's 0, 0. You can right away see this thing. And then this focus is 1, 2. So this slope is going to be 2 upon 1. So this slope has to be negative 1 upon 2, right? Yeah. Sorry. So this is going to be negative 1 upon 2, right? So y upon x will be negative 1 upon like 2y plus x is equal to some kind of constant. That's the thing. This will have slope of negative 1 upon 2. Yes. So it passes not 0, some kind of constant. It passes through 1, 2, right? So just put that in there. 1 plus 4, 5. So that's this line. And now we just figure out what these intersection points are. So first guy is y equal to x, right? Where did the 31, right? No, 30. So the first guy, just x equal to negative y or whatever. Just put that. You will get y is equal to 5 and x equal to negative of that. So negative 5,5. The other guy, put y equal to x. 5 third. 5 third. Yes. These are the points, of course. Okay, and then no, and then what? We have to find the midpoint. So that will be. Oh, and by the way, this is just the origin. Perfect, right? Yeah. Okay, what's the midpoint? So just take that 5 out. It's going to be negative 1, comma 1, and then this negative. That's going to be negative 2 upon 3. Half of that is negative 1 third. And then 1 plus 1 third is just 4 third. Half of this is like 2 third. So doesn't really matter what this thing is. I mean, just, yeah, like if we take that 5 third out, negative 1, 2. Yeah, that's this point. 5 third times negative 1, 2. So from here to here, the slope will just be 2 upon negative 1. So yeah. Wait, isn't 2 upon negative 1 the slope of... No, this slope is 2. This slope is negative 1 upon 2. This slope is 2 upon negative 1. Huh, whatever. Right, there we go. You got this point. Sorry, you got this, yeah, slope is just supposed to be negative 2. So this slope must be 1 upon 2. So y is equal to 1 upon 2x. That's our directrix. Cool, right? So just 2y minus x is equal to 0, whatever. So gonna put this thing over here to get the length. Which is supposed to be 4 minus 1 upon square root of 5. That's our length. So 3 upon square root 5. So m plus n has to be 8. Nice question. Next, 31. The equation of the line touching both the parabola and, okay, these two parabola is ax plus by plus c equals, so tangent to both of them. Then the value of a plus c is, oh, okay. I mean, we can just figure out the line, right? What's the big deal? Yeah. First guy, y equal to mx plus, a upon m, not 2a upon m, just a upon m, 1 upon m, right? Second guy, y, right, in quotation marks, y, which is supposed to be just x in this case, is equal to m times m 1 upon m in this because like x and y just switched, you know. And then here a, instead of that, let's say what was this? Okay, negative 8, right? This times of x is what? Y. Okay, plus a is negative 8, so negative 8, and upon 1 upon m, which is like this thing. Okay, so y is equal to mx plus 8m square. That's this line. So these must match. For that to happen, 8 times cube equal to 1, m is equal to 1 upon 2, right? So what does that mean? It means y is equal to 1 upon 2x plus 2. That's the line. So x minus 2y plus 4 is equal to 0. That's the line. Okay. Wait, why did they put it like this thing? I don't know. A plus b plus c is supposed to be just 1 plus 4 minus 2, which is 3. Although it could be anything, because I mean, you can just scale this up by, let's just say 2. So you got 2y minus 4. Yeah, then it could be 2 times of that. So this is like stupid. Why? Why did we do it like that? Anyway, doing it logically in quotation marks. What you get? Just get 3. Next, 32. From the point negative 1 comma 2, tangent lines are drawn to the parabola y is equal to 4x. Right? The area of the triangle formed by the chord of contact and the tangent is a. Then the value of a upon square root of 2 is. So once again, pretty much the same. Oh wait, it's on the directrix. It's on the directrix. Nice, I think. Right. And then you just want what? The area of triangle formed by the directrix to that tangent point. That length. What is that length supposed to be? So right, I mean, like t is just, you know, negative a comma a times of t1 plus t2. And let us say one of those points, let us say p, that was 81 square comma 281. So what's the distance between these two? So what's tp? That's going to be a, just take that a out, square root of t square plus 1 squared plus, so difference of these guys, right? T1 minus t2 square, right? But you know, t2 is just 1 upon t1, so it's like t square plus 1 squared upon t1 squared. So basically it's like a t1 squared plus 1, and then you got square root of 1 plus 1 upon t1 squared, which, yeah, a times t1 squared plus 1 to the power of 3 upon 2 upon t1. That should be the thing, right? Seems like that. Okay, that's this distance. And then similarly we'll have the other guy, so t2 cube, all of that stuff, right? So the other guy is like 1 plus 1 upon, yeah, it's like 1 plus t1 squared upon t1 squared to the power of 3 upon 2 upon, let's talk about the magnitude, you know. So right, yeah, I mean, I'm using t1 t2, but in the end it's supposed to be just a magnitude of these guys. So you got t2 right there, which is just 1 upon t1, and then it's going to come out, it's going to be 1 upon t power 3, right? t1 squared, that should do it. So the product multiplication is like, okay, t1 cube and all that stuff. So a square times, and then take that inside, right? t1 cube, take it inside, it's supposed to be t1 square, just like that. Wait, is that right? Can't be, right? It can't be. How can it be correct? Oh yeah, of course. Unexpected. Is that correct? How could that be? It looks correct at least. I think I messed up somewhere. No? t1 squared plus 1, that's squared, and that's upon t1 squared, right? So just combine, pull off, and plus 1 upon t. Yeah, it's supposed to be this power 3 upon 2, and that thing upon t1, right? And then you do the same thing for t2, just multiply together. Denominator just get, you know, I don't know, it's like 1. It's supposed to be negative 1, but yeah. And then 1 plus t1 squared times 1 plus t2 squared. Product of these these are supposed to be like 2 plus t1 squared plus t2 squared. All of that to the power of Well, 3 upon 2, right? That's what we are looking for. Okay, so that's the thing. Oh, we do know what T1 plus T2 is. We don't know what this thing is. We'll have to figure that out first. So A, oh look, the thing is like, hey, this is awesome. This is like awesome, isn't it? So you got 1 plus T1 square T2. Okay, okay, that's supposed to be 1 plus T1 square plus T2 square plus T1 square T2 square, which is 1, right? So got this thing. But you know, like T1 times T2 is just 1. So this isn't this thing just, you know, negative of 2 T1 T2, right? So it's like T1 minus T2 squared, but that of 3 upon 2. So this thing cubed dash with the area, of course. Okay, we don't want that. We want in terms of plus, right? So a times of 3 T1 square minus 2 plus T2 square. So then you just have, you know, plus T1 plus T2 square of 3 upon 2. That should do it. So really it's like a, and then you got, yeah, that's the thing, of course. Right, that should, oh, by the way, we should actually have a squared because, yeah. Hmm. Yes, because you have to multiply by 2 of these, right? Correct. It should be like this thing. Okay, cool. So now they've got this thing, half of that, because that's going to be the actual area of the triangle. Okay, so now it's going to put that in here. So for this, a is 1. We don't really care about, no, okay, that's the other equation. Oh, 32 as well, just got a as 1. Okay, cool. So it's just 1 upon 2 and then 3 plus, and what's T1 plus T2? Look at this guy. It's going to be this y coordinate. It's just going to be 2 because a is 1, right? So there we go. 3 plus 2 square. So 3 plus 4. 7 upon 2 is like, okay, 1 upon 2, 7 power 3 upon 2. Right? So is that not right? It must be. It has to be like that. What else could it even be? And then you want like, okay, a upon square root 2. But there's no square root 2 involved over here. What's going on? Then plus C2 has to be, something's wrong. Can you feel it? Right? Oh, it's supposed to be 4, right? Not 3. Okay, okay, that's what went wrong. Right, it should be 4 plus 4. Okay, okay, okay. Now it's correct. So it's just 8 or 3 upon 2, which is, you know, 2 power 9 upon 2. That thing upon 2, which is like 2 power 7 upon 2. That's our A thing. And this thing upon square root is like, okay, 2 power 1 upon 2, just divide by that. 2 power 6 upon is like about 3, 8. 8 is the answer. So 32, 8. Next, 34. Just 6 more. A line through the origin intersects, sorry, it's with 33 first. What am I doing? 33. This line cuts the parabola at the point A and B, and the value of P for which this angle is a right angle is just some angle AOB. What's O? O is the origin, I think. Okay, this line cuts this parabola at A and B. What x square was first? Hey, can't you just like homogenize this thing? Yeah, so just homogenize, find a pair of straight lines on which the intersection point lie, and then you got the thing. You will have the OA and OB lines, right? And then you can figure out that angle. Cool. So just homogenize this thing, and we want angle AOB to be 90 degree. Yeah, no big deal. We can do that. Just homogenize the thing. So first of all, like, okay, B is equal to x minus y, right? You got x square is equal to 4x plus y. Yes. So bx square is equal to 4x plus y times 2x minus y. So basically bx square plus, you know, y minus 2x and y plus 4x, we got y square plus 2x y minus 8x square is equal to 0, right? So y square plus 2xy plus b minus 8 times of x square is equal to 0. So we want this to be like y equal to m1x, y equal to m2x, but m1, m2 is equal to negative 1. Then of course this thing must be negative 1, right? So b minus 8 is equal to negative 1, b is equal to 7. That's the value of b, so that this happens. Right, so 7, there we go, next question. And this was easy. 34. Oh, and if you don't know what I did, this is called, I don't know who calls it like this, but it's called, I call it homogenization. That is, you make so something that is not homogeneous into something that's homogeneous. What it actually does is like it creates a pair of straight lines, uh, which contains the intersection points, right? So intersection points satisfy this pair of straight lines. Because I only did like linear combinations and stuff like that, I mean just use both of these together to figure out this equation, which is only satisfied by the pair of straight lines, by the intersection points, but also at the same time it's also satisfied by a certain point we want, in this case the origin, so 0 0. And yeah, just watch the other video that I made on this. I don't know what we call it. What did I call that video? It was homogenization or something. I don't know. No, it was like finding the angle um, on any point from any chord of a conic. Yeah, right. Watch that video. You will see what I did. Okay, 34. A line through the origin intersects this parabola at 2 points whose x coordinates add up to 17. Then the slope of the lines, so just some curve, whatever, is x coordinate. Oh, so intersects the parabola 2 points whose x coordinates add up to 17. Okay, so x1 plus x2, you know what that thing is. Through origin, you're saying. Oh, so just put y equal to mx everywhere. It is easy. It's easy. Just find an equation in x, quadratic. So it's like 2x. Is that square? Yes. Okay. Minus 9x minus 5mx. So minus 9 plus 5m times x plus 10 is equal to 0. So what's the sum of the x coordinates? That's going to be 9 plus 5m upon 2. And that is 17. So 5m is equal to 34 minus 9, which is 25. Yes. Okay. So m is just 5. The slope is 5. So 5 is the answer. Next question, 35. Yeah. If the circle, this circle and this parabola have a maximum number of common chords, then the least integral value of r is. So y squared equal to 4x is like this one somewhere there. This is entered at 6, 0. So yeah, 6, 0. And this has maximum number of common chords. So circle can only intersect at 4 points. So that's when you have the maximum number of common chords. So what must happen is like, okay, this circle should intersect at 4 points, right? Okay. For that to happen, its radius, okay, think about it, it's like increasing. At one point it will touch both of these, right? It will touch wherever you have the common normals, right? So at the t values which create normals passing through this point, it will touch at those points, and then just a little more than that, boom, you got 4 points, right? So not 2, you got 4 suddenly. And yeah, it's symmetric and everything, so that's when it's gonna happen, right? So the minimum value of r that this should happen, exclusive of course, that's just this distance from this point to that point. I mean, minimum distance from this to that, right? Yeah. Okay, no big deal. Let's do this thing. So what's this 4x, right? You got t square comma 2t as the parameterization. And from here, let's just assume that the normal assume that it's going from here. I mean, we know that's the condition for it to be the critical condition, right? Okay, so that just means y is equal to negative tx plus, and by the way, what's y? Y is like 0, it's like 6. So 0 is equal to negative 6t plus 280, a is just 1. 2t plus 80 cube t cube. So t cube is equal to 4t. Either t0, which would mean this, yeah, of course. So, right, I mean, I think that's the point where it's the maximum distance from, I don't know, is it the minimum distance or the maximum distance? I do not know. Yeah, right, I don't know what that is. Huh. At max, it can intersect at 4 points. That's what we want. Well, okay, we'll figure out what this distance is, both of these, and then, yeah. So, either t0 or you have t equal to plus minus 2. When t is 2, this just becomes, 4 comma 4, and this is like 6 comma 0. This distance is going to be, square root of 2 square plus 4, so which is like 2 square root of 5, yes. And then this distance is just 6, we already know that. Is 2 square root 5 bigger or 6 is bigger? Well, we know that square root 5 is actually less than 3, right? Yeah. So that means 2 square root 5 is less than 6. So this is the smaller distance, and then that just means it has to first touch this before it even can reach over there. So yeah, so the minimum integral value that this actually happens is when r is bigger than this thing, and it's like just bigger, just the right distance, right? So right, it's like square root of what? 4 to 20, right? Yeah. Square root 25, 5 is the minimum value. So 35, 5. Next, 36. Just 3 more. The slope of line which belongs to family of lines, okay, and makes shortest intercept on this. So x squared is equal to 4 times y minus 1. There is y minus 1 everywhere, right? What about this guy? Does this also have y minus 1? Okay, if I just put minus 1 over there, I have to put minus over there as well. So, oh, hey, I could do that. So just, yeah, you already got minus with, of course. Of course. So I'm just gonna shift the whole thing because we don't care about the coordinates, we care about the slopes, right? So shifting without rotating will preserve everything. So x bar equal to 4y. I'm just replacing y by 1 plus y everywhere. And then it's gonna be 1 plus lambda times x plus, so replace this or that. So cancel that out. Lambda minus 1 times y plus, okay, so minus 1, I think, equal to 0. So that's the other line, right? You are saying the slope of line which belongs to family of lines, okay, and makes the shortest intercept on x plus. So the shortest intercept 0, of course, yeah. I mean, whenever it's tangent, that's the shortest intercept, of course. And if it doesn't even cut this, that's, yeah, that's problematic actually. So I'm thinking that maybe you can have this being a tangent or something, right? Yeah, I think so. Okay, so let's try to simplify this first. X is equal to lambda minus 1 upon lambda plus 1. That's y minus 1, just like y, and then minus of the same stuff. So minus lambda minus 1, lambda plus 1. What I'm thinking is, right, so the tangent equation would be like xt is equal to y plus at square, right? A is just 1 t square over here. So if this like matches up with this thing, we're basically done, right? So that's going to happen whenever, so what you actually should have is that 1 upon t is just equal to lambda minus 1 upon lambda plus 1, and that's equal to, okay, all that stuff, and then upon t square, we'll say, negative of lambda minus 1 upon lambda plus 1, and that thing upon t squared. Or you can just say, okay, x is equal to, I don't want to use m, that's for slopes, okay, I reserve that for slopes. Use something as kx plus, sorry, t, okay, 1 upon k, right? So what we are saying is like, okay, this is k, sorry, ky, and this is like 1 upon k, so their multiplication must be 1. That happens when you are, this can't be 1, this can't be, it's square, okay, this doesn't make any sense. So it cannot be a tangent, that's what you're saying. Okay, so just slope of line which makes the shortest intercept, that's all our goal is now, right? I'm gonna graph this out first. Wait, you know what? We just say this thing is k. What's the range of k? I mean, this thing can be written as 1 minus 2 upon lambda plus 1, right? So the minimum value might be just 1. No, it can also go negative and everything, so it's okay. It actually goes from minus infinity to infinity. No big deal, right? So just call this thing as k, and then you just got x is equal to k y minus k, and I'm gonna draw the xy space differently so that it visualizes more. Then it's just x equal to 4y like this, and then the x-intercept is like minus k over there, and so y-intercept is y equal to 1, of course, right? Which is actually passed to the focus. So, oh, all of these lines pass through the focus. That's important. That's really important. Oh, and then you're saying this must have the shortest right? Isn't that like saying the focal chord, which is of the least length? That's of course the lattice rectum, right? So this will happen when it's completely vertical. And right, so like basically y is equal to some kind of constant or something. So y equal to 1, just like that. When does that happen? At lambda equal to -1. So just put -1 right there. It's gonna go out, and then this is not met. It's like non-zero, something finite. Y equal to 1. That's what you get, right? So yes, that just means lambda equal to -1 is the solution for which this gives the shortest intercept. So slope of that line, if lambda is -1, this thing is gone. Oh, slope is, so it's completely along the x-axis. It's gonna be 0. Huh. Right. So wait, what happened? 36 0 is the answer. Next, 37. Consider the parabola. Let delta be the area of triangle from the endpoints of its rectum at the points 1 upon 2 comma 2. Okay, on the parabola. And delta 2 be the area of triangle formed by the drawing tangents at P and the endpoints of lattice rectum. And at what? Sorry. Area of triangle from. Oh, okay. Then delta 1. Okay, this is complicated. So delta 1, that's like, wait, isn't this looking more and more like a hyperbola? Yeah, I mean, think about it. Just tangents at the, that's, no, it's not having asymptotes, because that's not gonna work. Lattice rectum, you draw these tangents. Okay, right. I mean, you could think of it as a hyperbola with a focus, the other focus, which is like very far away or something. No, okay, the other Directrix, which is far. No, hyperbola is a completely different species. Don't do that. Okay, lattice rectum tangents, got it. Some other point on this hyperbola, sorry, on this parabola, and they are drawing a tangent on that. Okay, so like this. Oh god, this tangent is just not nice, not nice. So if it was somewhere over here, it would be much more manageable, right? Yeah, okay, so a value is just 2. Okay, it is in fact over here, somewhere over there. Okay, fine. So that you actually get a representable value. Okay, so this area is what they're calling delta 2, and then delta 1 is, and okay, the area of triangle formed with end points of the lattice rectum and this point. So this triangle's area. Okay, this is complicated, isn't it? Right. Think there must be some way to it. Anything special we can do about it? No, just like just random points and random lines as well. Yeah. Right, and just random lines and points, not much is happening. Any property that, okay, I don't think that's going to happen anytime soon. Hey, it passes through the focus, right? So like this thing, okay, this tangent passing to the focus. Okay, cool. Angle same. Nah, not giving much. Wait a second. Oh, we already know it's supposed to be 2A and 2A. Ha. No, not helpful. So I hit somewhere over there and to figure what this complete length is. Damn. This is some easy way to do it. There's no easy way. You just have to do it like that. So some base, and then you got these two are the heights, of course. So okay, this is like right. This is the line y is equal to so t is in this case is 1. So m is 1 as well. So I mean it's 2a upon m. So x plus, and then 2a is of course is 4. So 4. There we go. And this would just be y equal to negative of the same stuff. So negative x will be 4, right? And you just want the sum of the y coordinates of these two decision points, right? So this tangent, what is that going to be? Oh, and by the way, you can actually figure out what this length is, right? Yeah, okay. Right. What is this? What is this tangent? This is 1 comma 1 upon 2 comma 2, right? So put that in there. Sorry. Y by 1 is like 2y is equal to 4x plus 4 times of 1 upon 2, which is going to be 2. So y is equal to 2x plus 1. That's this line. So, oh, we can just simply figure out what these actually are. Nice. And we know this has to be 2a, which is just 4. So 4 half is already there. You just want these heights. Then you have the area. So just that will give us delta 2. Delta 2 is going to be half, and then that times 4 is the base, and then some of these y coordinates. This has, so okay, y equal to 2x plus 1, put that in this, or just put x is equal to 4. So x is equal to y minus 4 in there. That's gonna work as well. So y is equal to 2y minus 8 plus 1. Y is equal to y is equal to 8 minus 4, 7. So this guy has 7 as the y coordinate, right? Okay, what about this? Put x is equal to minus 5 minus 4, right? In this thing. So y is equal to minus 2x minus 8. So that's 2y minus 8 plus 1. Yeah, that should make sense. So 3y is equal to negative 7. So just got negative 7 third is the y coordinate. So the sum is going to be, take that 7 out. 1 minus 1 third is just 2 third. There we go. That's our delta 2, right? Which is, so cancel this 2 out. It's supposed to be 28 upon 3. Delta 2 is just that. What about delta 1? Delta 1 is like just the, yeah, right. We'll have to do it the other way. I hate this. I really hate this. Fine. Or, I mean, you can just do this length. Okay, we know what this thing is, and then what's this thing? So its x coordinate is just 1 upon 2. So 2a was, sorry, x equal to a, right? That would just be 2, right? Damn it, did I do it correctly or not? I must have done this correctly, of course. What other thing could be there? Okay. Just keep going. Right, I mean, like that length is just 2a, which is, sorry, it's just a. Shit. It's gonna be a, then it must be, are you sure that's the correct thing? Is it a or not? What is this length? It's the length where, oh, okay. So whenever y is 0, it's just negative 4. It has to be 4. Okay, this is also 2a. Yeah, makes sense. It's gonna be on the direct. Shit, it's supposed to be on the Directrix too. Something's wrong. Something's really wrong about this. I messed up everything. I once again just did y equal to mx plus 2a upon m. That's not a thing. A upon m. Why do I always keep using this weird thing? Okay, it's supposed to be 2. It's supposed to be 2. All of this is wrong. Wrong. Right? Okay, this is wrong as well. This length is first of all just 2. So 2 and then half of that. We are trying to find out what delta 2 is. And then you need the sum of the y coordinates, right? Okay, so just figure out the point. It's like y equal to x plus 1. That's this other line. Right. So from here just get x is equal to minus 2 plus y. Let's put that in there. Y is equal to minus 4 plus 2y plus 1, that is y is equal to 3, right? From here you get x is equal to minus y minus 2, just put that in there. So y is equal to minus 2y minus 4 plus 1, 3y is equal to minus 3, so y equal to negative 1. Sum of the lengths, it's going to be 1 plus, okay, not the sum of the y coordinates, the sum of the lengths, y, the difference of the y coordinates basically, right? Yeah, that's going to be 4. So delta 2 is just 4, you know. What about delta 1? So delta 1, okay, what's this distance? So this is at a comma 0, which is 1 comma 0. Okay, sorry, it's 1 because, no, it's 2 because, yeah. So this is at x equal to 2, and this thing is at x equal to 1 upon 2. So that distance is going to be just 3 upon 2. So 3 upon 2 and then half, and this base length, which is 4a, that's our illustrator was like 8. Okay. So 4, this cancels, 2, 6, there we go. And yeah, it is not working. What's going on? I don't get it. What went wrong? What went wrong? Huh. So 2, of course. Yeah, so 2 minus 1 upon 2, that's going to be 3 upon 2. It has to be like this. 6 upon 4. So, okay, I'm just going to report this. 3 upon 2 is the answer. 38, last question. It's crazy. Maybe there's like a more general formula for this. I don't know. Whatever. Next, it's got 38. Last question. Let S be the focus of the parabola and PQ be the common chord of the circle and the given parabola. It passes to 0, 0, I think. Okay. S is just a focus of the parabola. So the focus of the parabola, okay. And PQ is the common chord of this circle and the given parabola. Okay. The area of triangle PQS is, it's crazy. It's at 1, so this is centered at 1 comma 2, right? Yeah. Hey, isn't that just, no, it's not, so this would be 2 comma 4. 2 comma 4 is something like that. Okay, and 1 comma 2 is, you know, just this thing, that's our center. It's gonna pass to the center, of course. Okay, yeah. And you want the area of triangle PQS. PQ is the common chord. But isn't there going to be like multiple common chords? Because, no? Wait, what? I don't get it. Oh, hey, okay, this is the diameter. This is the diameter. Oh, this focus is actually on the thing. Oh, wow, that's awesome. So, you know, like, okay, this is also going to be on that. There we go. This shouldn't thing. It's passing through that. Okay, fine. Yeah, I think that's nice. Okay, so now you know how the circle is, right? And the common chord is just this thing, of course. Right, this is the common chord. And then you want PQS, this area. That's easy actually. I mean, this is just going to be equal to 2 and this is going to be 4. So, yeah, half of that. Like, okay, half of 2 is just 1 and then 4. So 4 is the answer. Next. Oh, it's done. Yeah. So, this is it. Should I check this? I think I should. This is 2C, right? I don't know how many wrong I'll get. So first you got 4, 7, 0, 9, 2, 8, then 2, 0, 6, then 1, 5, 3, then 1, 2, 8, wait, 16, right? 4, 6, 4. Oh, till now it's going nice. 184. Okay, then 22. 0, 3, 2. Okay, it's supposed to be 3. Then it's supposed to be 2. Okay, 25 is 4. This is 2. This is 2 as well. And 28, 99901. So triple nine. Oh, it was a. Wait, no. How can that be correct? Is it not just 990? Was it a 1000 or something? Maybe. But then why do you have 100? That's not making any sense. Yeah, because this is the thing. Crazy. Oh, wait, what happened? Okay, okay, we'll figure that out later. So this is somehow wrong. Fine. 29, 2. That is 2, not 8. This is like 11. Wow. 3, 8, 7, 5, 5, 0, 3, and this is 4. So these are wrong. Let's see what went wrong. So first 23, right? Yes, select size what? It's 2C. It's 3. And 2C 23. This cannot have a common normal other than x's. Okay, if these have a common normal, then of course whatever for these. For the first guy, it's going to be y is equal to negative dx for mx plus 2a. Sorry, mx, not that. So it's 2am. A is just, that's there, 2am plus am cubed. For the second guy, y is equal to m times of x minus b minus 2 times of a minus 1 times m plus a minus, oh, it's supposed to be negative. A minus 1, and then you got m cubed, right? So cost must be the same, which means you're going to take that m out anyway. So it's minus 2a minus a m squared is equal to minus b minus 2a minus 1 is like minus 2a plus 2, and then so it's minus am squared plus m squared, right? Cancels everything. Start squared, sorry. M squared plus 2 is equal to b, so b must be 2, right? Should be bigger than 2, so that's 24th. Oh, 24th, sorry, 23rd. 23rd is what went wrong, huh? So it's not 4, it's 3. Okay. So there's an area enclosed by the common tangents to this and that, and the chord of contact is Ka square, then K equals, right? So y equal to mx plus a upon m, right? That's the thing. This must be, the tangent to this thing as well, so 0, 0, m plus a upon m. Sorry, x is there, right? So okay, just a upon m upon square root of m square plus 1. This must be equal to the radius, which is a upon square root 2. That means oh shit, okay, that's where I went wrong. It's supposed to be 1 upon m, right? So 2 upon m squared is equal to m squared plus 1, means m power 4 plus m squared minus 2 is equal to 0, which means m squared minus 2, sorry, plus 2, and then m squared minus 1 is equal to 0. This cannot be 0. This has to be 0. So m has to be, maybe I did it with t or something, I don't know. The slope has to be plus or minus square root 2. Okay, cool. Yeah. So Let's do it. You want what? Common tangents to this thing and the chord of contact. What's the x-intercept? So whenever y is 0, x-intercept is just going to be like negative a upon m, which is negative a upon m squared, and m squared is just 2, so negative a upon 2, right? So you got this as the thing somewhere, like, okay, got this thing. Yeah, and once again, what was that formula that we discovered for this area? It was like, I forgot that area formula once again. Okay, no, that formula was when it was perpendicular. It's not perpendicular right here. Anyway, so what's the chord of contact? So I put that here. So y by 1 is y is 0 for this guy. So just 0 is equal to 4ax, okay, 2a. I mean, it's going to be 0 anyway. Just x plus x not equal to 0. So x is equal to minus x naught, which is a upon 2. So a upon 2, right? So this is going to be a. A is this distance, half a, and then this whole thing, right? So at a upon 2, what's the y coordinate? So y squared is equal to 4a times a upon 2, which is 2a squared. So y coordinate must be square root 2 times a. So it's going to be 2 square root 2 times a. That's this length. Yeah. Yeah, of course. So, okay, this cancels. It's square root 2 times a squared. So, wait, that's what k is. It's not, it's why this is square root 2 of a. What? Doesn't make sense. So something went wrong, right? That must be the only reason that I got square root 2 right there. So it's like that. Oh, sorry. Why did I do this? It's supposed to be 1, not okay, it's supposed to be 1. So y equal, yeah, I mean, okay, this is supposed to be minus a upon x minus a. This is supposed to be a. Right. Now starting to make sense. It's gonna be 2a right here. This whole thing is just 4a. So 2a times 4a upon 2, which is 4a square, of course. Then k must be 4. Then this thing has to be 4 as well. I don't know why they put 3 over here. I don't know. Okay. Yeah, so it has to be 4. No other way. Okay. In fact, I don't think it's even worth doing all of the checking because, yeah, who does even really care about this? Okay, so this is it. And oh, so 28. What's this? A 100 or 8,000? 100, right? It must be this thing, not that 990. No, that's not correct. Can't be, right? Okay, so this is it. I'll see you guys in the next video. Bye.